Welcome everyone. Welcome to today's live stream. It's Friday, so it's Nim language. And today we're gonna start something big. We're gonna try to learn from the Nim Manual. It might be a little bit more dense, especially in the beginning, but we'll see what we can get out of this, okay? Let me get set up here. All right. Let's get to Nim, and if you want to follow, we can just go to nim-lang.org. Okay, or just search for the Nim language. And Nim 208, interesting. New versions are out. Okay, so we go to documentation. And here in the documentation, there will be language manual. All right. This is what we're gonna try to go through today. We'll see how far we get to. I'll try to, focus on whatever is being explained and actually understand it. I kind of recall that few first chapters will be a little bit abstract or something. We'll see what happens. All right. The Nim Manual. Authors Andras Rumpf and Zachary Karajov. Complexity. Complexity seems to be a lot like energy. You can transfer it from the end user to one or some of the other players, but the total amount seems to remain pretty much constant for a given task. Okay, makes sense. About this document. Note, this document is a draft. Several of Nim's features may need more precise wording. This manual is constantly evolving into a proper specification. The experimental features of Nim are covered here. Yeah, it's a separate document. Assignments, moves, and destruction are specified in the destructors document. This document describes the lexis, the syntax, and the semantics of the Nim language. To learn how to compile Nim programs and generate documentation, see the compiler user guide and the docgen tools guide. The language constructs are explained using the extended BNF. It's some kind of notation. I don't remember what it exactly stands for, but it's basically a documentation of that you could just provide to some kind of syntax analysis, whatever, and that will help basically parse Nim language, in which A* means 0 or more A's, A+ means 1 or more A's, and A ? Means an optional A. Parentheses may be used to group elements. Oh wow, we're actually going through this to understanding it. Sure, why not? The ampersand is the look-ahead operator. Ampersand A means that an A is expected but not consumed. It will be consumed in the following rule. Okay. The pipe and / symbols are used to mark alternatives and have the lowest precedence. / is the ordered choice that requires the parser to try the alternatives in a given order. / is often used to ensure the grammar is not ambiguous. Non-terminals start with a lowercase letter. Abstract terminal symbols are in uppercase. Verbatim terminal symbols, including keywords, are quoted with a apostrophe. An example. If statement is the words if, so this is the verbatim terminal symbol. It's an expression. Okay, so we have if, then we have an expression, then we have the colon, then we have statements. And then in parentheses, we have else if an expression and colon and statements. And that's the star, a star. Star means 0 or more, okay? So we can have else if statement, 0 of them or more, while else means that's an optional, so it's none or just one. Okay? That makes sense. And after else, we don't have the expression and no colon. Huh, interesting. I thought else would have a colon. Oh, because the colon can be omitted, right? The colon would need to be there if we start a new block only. Huh. Go figure. The binary, what do you call that symbol? I saw it named a few ways. We'll call it roof, because it looks like a roof of a house. A roof star operator is used as a shorthand for 0 or more occurrences separated by its second argument. Likewise, roof plus means 1 or more occurrences, so A roof plus B is short for A. Then we have B and A. Oh, B after A? No, A after B. Oh god, why are we reading that? Okay, great. Other parts of Nim, like scoping rules or random semantics, are described informally. Thank you. I am not looking for like super formal thing. Okay, so we're going through the first chapter now, definitions. We'll see what we can learn. This could be easier, a little bit larger for everyone, right? Nim code specifies a computation that acts on a memory consisting of components called locations. A variable is basically a name for a location. Each variable and location is of a certain type. The variable's type is called static type. The location's type is called a dynamic type. The variable's type is called static type because this is what we define, right? We define a variable. While the location's type is called dynamic type because location is allocated, memory is allocated during runtime, and the same memory could have different types of data in it throughout the life of the program. Okay. If the static type is not the same as the dynamic type, it is a supertype or subtype of the dynamic type. Wow, this is a mouthful. If the static type is not the same as the dynamic type, it is a supertype or subtype of the dynamic type. Okay, so basically, all right, so basically we're saying that if the data in memory is of type A, the static type, if it's not exactly the same, it's either a subtype of that thing, so whatever inherits from it, or a supertype, which is the opposite. Interesting. I guess they're somewhat compatible, and that's what matters here. Interesting. An identifier is a symbol declared as a name for a variable, type, procedure, etc. Okay, so that's a very important word here, identifier. We'll see it everywhere, okay? So the identifier can be either a variable name, it could be a type, could be a name of a procedure. Whatever we name is basically an identifier. The region of the program over which a declaration applies is called the scope of the declaration. Okay, I think we're all familiar with the scope. Scopes can be nested. Yes, because you can have a procedure within a procedure. You can have a loop within a loop. Each has its own little bit smaller scope that is considering only I presume, specific set of identifiers within it. The meaning of an identifier is determined by the smallest enclosing scope in which the identifier is declared, unless overloading resolution rules suggest otherwise. Exactly. So the whole idea is that if we have, a procedure within the procedure, that nested procedure is the one responsible that, can add more, can do something else within its own scope that won't be affecting the one outside of it. So you basically don't have things like the var keyword in JavaScript that would affect something outside of scope. An expression specifies a computation that produces a value or location. Okay. So an expression specifies a computation that produces either value or location. So location, I guess, in this case, is a pointer somewhere in memory, or value, which is the actual value that we can apply somewhere. Okay, so I guess this is like an intro into value types and reference types. Maybe that's what it means. Expressions that produce locations are called, I presume it's L. Let's see if it's an actual L, because it looks like an I, but I'm not sure. We can just do this, right? Let's do this stuff. Wait. Const I is, and I should be able to paste it. Come on, I should be able to paste it. It's plain text. I didn't copy it. There we go. Where was it? Where's our... Oh, there we go. Copy. Paste. No, it just refuses. What the heck? Seriously? Can I paste it here? I can. Can I paste it here? I cannot. Okay, that must be this whole arc thing. Whatever. To uppercase online. Whatever. Stupid. Paste. Uppercase. L value. There we go. It's an L value. It would be nice to kind of market that, with capital L. That's an L value. So locations are called L values. An L value can denote either a location or the value the location contains, depending on the context. Okay, so I guess that L value basically is our reference type. Something that can be pointed to, and we either, depending on context, we operate on that pointer as a reference or on its actual value. All right. A Nim program consists of one or more text source files containing Nim code. Makes sense. It is processed by a Nim compiler into an executable. The nature of this executable depends on the compiler implementation. It may, for example, be a native binary or JavaScript source code. Okay, that's the whole idea about Nim having multiple backends. Let me just refresh the one thing I forgot to click. There we go. In a typical Nim program, most of the code is compiled into the executable. However, some code may be executed at compile time. That's very important. This can include constant expressions, macro definitions, and Nim procedures used by macro definitions. Most of the Nim language is supported at compile time, but there are some restrictions. See restrictions on compile time execution for details. We use the term runtime to cover both compile time execution and code execution in the executable. Oh, okay. Okay, so compile time, yeah, because during compilation it kind of has its small version of a runtime. And that's the idea here, I presume. The compiler parses Nim source code into an internal data source called the abstract syntax tree, AST. Okay, so if you deal with macros in Nim, you'll be dealing directly with the AST. Then, before executing the code or compiling it into the executable, it transforms the AST through semantic analysis. This adds semantic information such as expression types, identifier meanings, and in some cases, expression values. An error detected during semantic analysis is called a static error. Exactly. So if you have, your nim suggest, that's what nim suggest does. It turns things into abstract syntax tree and, tries to compile it. Like right before compilation, it does all those checks. And if there's an error, like, oh, the types here are matching or whatever, it throws out an error without actually compiling the whole code. So errors described in this manual are static errors when not otherwise specified. Okay, so by default, it's all static here. Okay. A panic is an error that the implementation detects and reports at runtime. Okay, the method for reporting such errors is via raising exceptions or dying with a fatal error. That's funny, dying with a fatal error. However, the implementation provides a means to disable these runtime checks. See the section pragmas for details. Okay, so we have some kind of control here. When a panic results in an exception or in a fatal error whether a panic results in an exception or in a fatal error is implementation specific. Okay. Thus, the following program is invalid. Because this one. Even though the code purports to catch the index defect from an out-of-bounds array access, the compiler may instead choose to allow the program to die with a fatal error. So we have an array from 0 to 1, and we specify index of 5. We try to access the index of 5 and put n in there. And if there's a problem of like index defect, echo invalid index. So, we're trying to do something, right? And if there's an error of index defect, you might think that it's gonna just say it, but the compiler may instead choose to allow the program to die with a fatal error, so it's just not gonna throw an exception, it's just gonna die. Interesting. The current implementation allows switching between these different behaviors via -- panics on or off. Oh, that's cool. So you can actually decide if you do something crazy like, index out of bounds, if you want to be able to catch that error and just in case correct it, which would be, I guess, very, very interesting when it comes to, high resiliency apps or whatever. That, you just catch the errors and, at least everything else doesn't die. Or it's absolutely necessary that your program is 100% correct and, So I can see that you could develop with panics on. And then when you're sure that everything works and you have a million ways to catch those just in case errors, then you could in production have panics off and just super strong logging so that you can make sure that if something goes wrong It's not the end of the world. Your production won't die. It's just some specific request. Maybe it will be denied or error. Interesting. When panics are turned on, the program dies with panic. If they are turned off, the runtime errors are turned into exceptions. The benefit of panics on is that it produces smaller binary code and the compiler has more freedom to optimize the code. Oh, that makes sense. So there are less checks, probably. Yeah, less checks, and we can optimize things a little bit more because we're not putting possible errors everywhere. Interesting. An unchecked runtime error is an error that is not guaranteed to be detected and can cause the subsequent behavior of the computation to be arbitrary. Unchecked runtime errors cannot occur if only safe language features are used and if no runtime checks are disabled. Oh, so the moment we start using pointers and other unsafe features, then those unchecked runtime errors can occur. Other than that, we guarantee that no such things will happen. Okay. A constant expression is an expression whose value can be computed during a semantic analysis of the code in which it appears. It is never an L value and never has side effects. Constant expressions are not limited to the capabilities of semantic analysis, such as constant folding. They can use all Nim language features that are supported for compile time execution. Okay, since constant expressions can be used as an input to semantic analysis, such as for defining array bounds, this flexibility requires a compiler to interleave semantic analysis and compile time code execution. Okay, so basically what it means that we can have constant expressions, as in some code that will execute during compile time and result with concrete value. And that means that with this whole interleave semantic analysis and compile time code execution, what that means is that, you can have basically constant expressions depending on other constant expressions and, use it throughout, and the compiler will basically figure out how to get and compile the whole thing. Okay, that's great. We saw this in action. It's absolutely awesome. It is mostly accurate to picture semantic analysis proceeding top to bottom and left to right in the source code, with compile time code execution interleaved when necessary to compute values that are required for subsequent semantic analysis. We will see much later in this document that macro invocation not only requires this interleaving, but also creates a situation where semantic analysis does not entirely proceed top to bottom and left to right. Yeah, you can do crazy stuff with macros. All right. Hey, that was the first chapter. That wasn't bad. It was, definitions, that's for sure. So we know about L value. We know about constant expressions, various errors. We learned about turning off panics, which is interesting. And all that stuff. Cool. Let me just drink something. And we can move on to lexical analysis, encoding. All Nim source files. Oh, I didn't hit record. I'll start recording now. I guess I'll need to re-record definitions at some point because I want to have it in a video form, all right? So, lexical analysis, encoding. All Nim source files are in the UTF-8 encoding, or its ASCII subset. Other encodings are not supported. Any of the standard platform line termination sequences can be used. The Unix form using the ASCII LF line feed, the Windows form using the ASCII sequence CRLF as in return followed by line feed, or the old Macintosh form using the ASCII CR, return character. All of these forms can be used equally, regardless of the platform. Okay, so just as long as you're UTF-8, you're good. Cool. Indentation. NIM's standard grammar describes an NIM's standard grammar describes an indentation-sensitive language. This means that all the control structures are recognized by indentation. Indentation consists only of spaces. Tabulators are not allowed. So this is straight up like in Python, although I don't know if Python prohibits tabs or not. But yeah, this language definitely stops the conversation of spaces versus tabs. The indentation handling is implemented as follows. The lexer annotates the following token with the preceding number of spaces. Indentation is not a separate token. This trick allows parsing of Nim with only one token of lookahead. Okay, that's crazy. The parser uses a stack of indentation levels. The stack consists of integers counting the spaces. The indentation information is queried at strategic places in the parser but ignored otherwise. Okay. The pseudo-terminal indentation, I guess, denotes an indentation that consists of more spaces than the entry at the top of the stack. Okay, so this is more, this is equal. This indentation equals an indentation that has the same number of spaces, and DED is another pseudo-terminal that describes the action of popping a value from the stack. Okay, sure. An indentation then implies to push onto the stack. Okay. This is some weird low-level stuff. With this notation, we can now easily define the core of the grammar. A block of statements, simplified example. So we have if statement, if expression, and then we have the same indentation will be else if, okay? And the same will be else, all right? And what about the statement? Simple statement is if statement, or something else, While the statement is indentation larger, whatever, and then statement with the same, oh geez, a list of statements, or simple statement. I am not gonna try to read those anymore because we all know Nim code. Let's keep it separate from the whole formal implementation or definition of how to parse Nim language. We just learned that, okay, indentation is important. Let's not hyper focus on that. This is if we were writing some kind of, something that parses Nim language, then sure that would be helpful, but not in our normal reading. Comments. Comments start anywhere outside a string or character literal with the hash character. Comments consist of a concatenation of comment pieces. A comment piece starts with a hashtag and runs until the end of the line. The end of line character belongs to the piece. Okay. If the next line only consists of a comment piece with no other tokens between it and the preceding one, it does not start a new comment. Okay, so a situation like this, where we start a comment here, it just continues, and it continues, So basically, Nim language will consider this as a single comment. And the thing with Nim language, which is interesting, is that comments are actually part of the AST, as far as I know. It's like, during the initial processing, they're not fully ignored. So I guess one could use comments in macros. I know, crazy idea, but who knows? That'll be a way to go around few weird quirks. Definitely something to check out. Let's actually check it out right after this. Documentation comments are comments that start with 2 hashtags. Documentation comments are tokens. They are only allowed at certain places in the input file as they belong to the syntax tree. Oh, okay, so I guess only the documentation comments will belong to the syntax tree. So let's figure some things out, okay? Let's go to Claude AI. We're gonna ask a new question to our Nim expert that actually knows the whole documentation. I made a quick little thingy. So let me think. How do I get an AST of a specific piece of Nim code? I can run it probably and see what's gonna happen. Okay, Claude is contemplating. I just don't remember how that thing was because I want to just put comments in there and just see. Macros module, AST, quote, do, echo AST, tree representation. There we go. So prompt out, use the dump tree macro. Okay. For inspecting ASTs. There we go, dump tree. Even better. mdump AST gen macro. If you want to see the AST as Nim code that generates that AST, let's just go with this one. And let's open up. I believe we had something like random at some point, right? Let me just find it. Not nowhere here. Just give me a second. Okay. We've got our random. And we can just place our code here, save it, and I believe we can just run it, right? So we get statement list command, which is echo, and then string literal hello world. So what if I'm gonna do, this is a comment, okay, and run again. Same thing, okay, nothing changed. But what if, I don't think I will be able to do this, right? This will probably complain that it shouldn't, oh, there we go. It's a comment statement. This is a comment. So that means that we could, in theory, use documentation comments as an expected input of a macro, like, this is a macro. And therefore, the comment isn't subject to analysis of, this doesn't have to obey the syntax of Nim language. And we can probably just do a few of them, right? We'll save it, we run it. And yeah, it's just one comment here. Ooh, that could be interesting because you could probably extract that information and, I know, do some string stuff and turn it into more Nim code. Very interesting. Can already see a situation where you could just dump code in a different language and translate it to Nim. Okay, this is interesting, very interesting. Little digression, but hey, documentation documentation comments are part of the AST tree, so you can get to them from macros, and that's how I believe that's probably how documentation is automatically generated. Very cool. Yeah, it's part of the language rather than going over the code, huh? And then we have multi-line comments. Starting with version 0.13.0 of the language, Nim supports multi-line comments. They look like we have hash and the open square bracket. We have multiple lines of the comment and equivalent closing. Multi-line comments support nesting, so you can have one within the other. And I guess, yeah, this symbol won't stop this first comment. Yeah, that's awesome. This way you can comment out something that already has a comment and, not worry about it. This is a very, very, very good feature. Multi-line documentation comments also exist and support nesting too. Oh, that's even more awesome, especially that you can... Oh, wow. Yep, awesome. You can drop something here without any stuff around it. That's super awesome. You can also use the discard statement together with triple quoted string literals to create a multi-line comment. Discard and this thing. But what is it gonna produce? Is it going to produce the comment statement? Gonna paste it here. Okay. Because this started multi-line comment, this ended it. Save and run. Oops. Will it actually show up as a comment? No. This just shows up as a discard statement with a triple string literal. So the compiler will optimize it by totally getting rid of it, I presume. But it isn't a comment statement. It's a discard statement. So, yes, this is a fake comment. This was how multi-line comments were done before version 0.13.0, and it is used to provide specifications to Testament test framework. Okay, I see. It got stuck in the past. Don't use it anymore. Identifiers and keywords. Identifiers in Nim can be any string of letters, digits, and underscores with the following restrictions. Okay, and the identifiers. Any string of letters, digits, and underscore. Okay, so no other characters. So they need to begin with a letter. They do not end with an underscore. And 2 immediate following underscores are not allowed. Okay. I guess there are reasons for this. All right. Sure. Hello, CPN. Welcome back to the live stream. Why isn't anyone here? That's just my live streams. Nobody's here. I just talked to myself. By the way, I have a link for you if you're here. Remember the whole mermaid fight yesterday? I'll send you a link because I actually fixed it and randomly turned it into an article about it. So here's the link for you to enjoy. I solved the problem. The only problem was don't delete the code block because deleting the first code block removes styles for the rest of the code blocks and problem solved. That's that. Alrighty. So let's get back to, by the way, how are we doing today? Is it today better than yesterday? Okay, so basically identifiers could be, yep, just don't put weird stuff in it and always start with a letter and you're good. Okay, and just avoid underscores unless it's just one and not at the end. That's that. Currently, any Unicode character with an ordinal value of larger than 127 as a non-ASCII is classified as a letter and may thus be part of an identifier, but later versions of the language may assign some Unicode characters to belong to the operator characters instead. So the following keywords are reserved and cannot be used as identifiers. So there's plenty of them. Let's go through them and figure out if we know about them. CPN says everything's going right. That's great to hear. It would be great if every day was all right. Okay, we know about address and as ASM as an assembler. Okay. Bind, don't know that one. Block, don't know about that either. Or no, block, we can define blocks with that. So I know that one. Break, yep. Case, cast, concept, const, continue, and converter. Heard about all of them. Defer, discard, distinct, div, and do. Yep. LF, else, and enum, except. Huh, interesting. And export. Export. That's interesting. Finally, for, from, and func. If, import, and include interface is not iterator. These are all good. Let macro method mix in. That's a new one. Mod. Nil, not in. Object off or out. That's another. There are a few here that, are not being, that I'm not familiar with. Proc, pointer, raise, ref, return, shift left, shift right, static, template, try, tuple, type, using var, one while, XOR, and yield. I guess few here are not being in use right now. So, let's see. Which of those keywords aren't currently used in the Nim language? I wonder if it's gonna be able to answer that. And we just paste it all and send. CPN is currently painting his website with CSS. Ooh, that's fun. It's kind of weird, but it's satisfying when it finally works. Oh yeah, when it finally works and it doesn't look like, crazy stuff, it's really satisfying. 100% agree. Not currently used or less common. Interface. Yeah, that's true. There is keyword interface defined here, but it's not in use because there are no interfaces. I want interface. Mix in. It is rarely used and its functionality can often be achieved through other means. Really. Out. While this exists as an experimental feature and not commonly used in regular Nim code. Okay. And possibly unused or rarely used. This keyword not mentioned any core language documentation using. Okay. Tell me more about the usage of mix in and out. Because I have not heard about them. Mix in declaration is used to explicitly bring in symbols into the current scope. It's primarily used in templates and macros to ensure that certain symbols are available. Haven't heard about it. Don't know if that's made up. I guess we'll find out after we read the manual. And about out, the out parameter is an experimental feature of Nim similar to var parameter, but with an important difference. An out parameter must be assigned a value. Really, this is defined. I guess when we read through experimental documentation, we'll learn about it. Interesting. Yeah, from the Nim Manual, and really, it is in manual. I'd be probably not in there. Come on, Nim Manual, search. That's the only thing. Okay. I guess if I'll scroll back up, we can go to the experimental features and out end. There we go. It is here. How about mixin? Not here. And oh, mixin statement. Symbol can be forced to be opened by mixin declaration. Okay, so that one's used. Okay. I guess AI didn't lie this time. Cool. So let's get back on topic. It's enough of those shenanigans. All right, we finished with all the symbols. Oh, this is gonna be a fun one. This is a really fun one. We already went over that a long time ago at some point, but identifier equality. Two identifiers are considered equal if the following algorithm returns true. And identifiers in this case is basically something that we named, like a proc or type or variable name, operator, which is basically a proc. So we have same identifier, identifier A and B as string. So if they are both, if the first letter is exactly the same, okay, and later replace all the underscores with nothing, so it just completely ignores underscores, and to lower case, okay, so that's it. CPN says, I was interested in Nim a while ago, but I didn't like that it uses white space instead of curly brackets. Yes, I kind of like curly brackets more because it's harder to mess your code up when you're refactoring. 100% agree. When it's already written, it's nice and readable, but not when you need to make edits. I messed up some code a lot at some point. You just need to save and commit a lot. Okay, so this is super awesome. That means only the first letters are compared in a case-sensitive manner. Other letters are compared case-insensitively within the ASCII range, and underscores are ignored. Exactly. That's the crazy part. We already went over that. This is a rather unorthodox way to do identifier comparisons. This a rather unorthodox way to do identifier comparisons is called partial case insensitivity and has some advantages over the conventional case sensitivity. It allows programmers to mostly use their own preferred spelling style, be it ham style or snake style, and libraries written by different programmers cannot use incompatible conventions. A Nim-aware editor or IDE can show the identifiers as preferred. There's none of that yet. I guess here's a challenge, right? Another advantage is that it frees the programmer from remembering the exact spelling of an identifier. The exception with respect to the first letter allows common code like var foo to be parsed unambiguously. Yeah, because types are supposed to start with a capital letter. Note that this rule also applies to keywords, meaning that not n is the same as not n. Oh, that's crazy. And not n, a lowercase version. Yeah, not n is preferred way of writing keywords. Historically, Nim was a fully style insensitive language. This means that it was not case sensitive and underscores were ignored, and there was not even a distinction between foo and foo. Okay, wow. So this part here, the additional thing about it is that it treats emojis ASCII way, which means that each emoji is made of several symbols. And therefore, it's possible to just have emojis as parts of your names or as full whatever names. So, if we want to have some code, we can easily do, let's do something simple. Type, okay. Let's make it, what could we do? Something, I don't know. Person. What's this? Oh. But I clicked. Person. Let's say that tuxedo. There's no like normal, whatever. Person. Okay. Type person is object. Okay. And then we're gonna have that. What do they have? Hand. And that will be an integer, right? Or I would say integer. Whatever, integer. And because of that, we can actually do even crazier stuff. Let's make type number. Okay. Is integer. Okay. We just made an alias for it. And we can say that hand is of type this. How many hands? Let's do the same thing with something like a leg. This is stupid. Leg. Okay, how many legs? And I don't know what else. Emojis is variable name. Yes. And you can do combinations of emojis to do something. In this case, these are actually type names. Okay. So if we have that, we can actually do var and yeah, a var with a name like this emoji. I can probably make it a little larger to make it even easier on stream with tiny emojis. So this will be the variable name of type person, in this case, is, and we create new person with one hand and two legs. Okay. Sure. And I believe we can actually say that, is there like I want to push it a little bit more. There's one. And can I make it static of type number 1? Something like this. I just wonder if I can make it to be, I guess, not as a type, right? Constant. Just writing things like that is very confusing. Let's just define it as a type because I guess it needs that. Is this. And then we're gonna have 2 is that. Why doesn't like it? Without indentation. Save. It should be fine because I want to say that this will be 1 and this should be, come on, I'm pressing everything that I can press that is wrong. I don't understand that part. Why isn't it allowing me to do it? Identifier expected, but found 1. Not everything works. var. Go figure. Something just stopped working. Don't know why. But yeah. It's not unique, so I don't know. But that's is supposed to work, and I just do echo person.hand? Will that work? No. There's something wrong here, I guess, with the colon. I don't know if it needs a space or something. Yep, not every emoji will work. Yeah, near the colon, it shows as if there was an invisible character, or maybe it actually added an invisible character. Ah, maybe it added. Do this again. Yeah, look at that. It adds something. So, added once. So I guess that emoji is just wrong. If I would use this one's fine. Okay. It's just number emojis are weird, I guess. 2. There's something with 2. Oh dear God. Yeah, the hour 2 will be this. And if we'll do 1, hour 1 is this. So even worse. There you go. What? Oh, the thing doesn't escape properly. That's what it is. Save. Run. And we got response 1 because that person has one hand. And yeah, you can write a lot like that. And you can make, I don't know, ABC, okay? While this will be ABC, while this will be A underscore B underscore C. And it also works because these are all equal. Yep, weird stuff. But if you want to confuse people, sure. Although I feel like sometimes just throwing an emoji into a variable name or somewhere would actually make sense. Something like, you know, I guess you could make fire emoji or whatever to represent error or something like that, exception. Yep, and all your exceptions will be just fires. This way you can spot them from far away or something. Or if you prefer to make exceptions as enums, okay, and you have, you know, I know, code 404, right? Code 500 and whatnot. Then you can basically say, whatever, fire this and fire that, or you can just name them that way, and you just see where you have that. Status code error or whatever. Nothing's stopping you from doing that, so you can make your code kind of stand out in some spots, but it's really easy to just make it absolutely unreadable. Yeah. And you can, and another thing is that you can probably specify one extra thing. We could do, let's say we have the person, right? Let's specify a procedure. And that procedure, do we have something like mix, blend, smoothie, fan, or whatever, combine. There's a knife, kitchen knife. Procedure kitchen knife that will take A as a person, ABC. Let's just get rid of this ABC because it's just kind of annoying. There we go. So we can define a procedure. But let's not define it as a procedure. Let's actually define it with backticks as an operator. So we'll take A and B of a person and return a, gosh, copy paste person. Okay? And what it will do is basically create a new person, which is number of hands combined, numbers of legs combined. So we can have a person number 1, and then var and person. This guy. This is so stupid. And this thing, you can't even read the difference. And we could do basically echo this knife this. I guess spaces in between. Attempted call routine found this. Something's not working. That's interesting. Why not? Declared byte not used. Do I need to use backticks for that? That would be stupid. No. Because it's an operator, so it shouldn't really have a problem with that. Why is it trying to call this routine? This is an operator. That shouldn't be a problem here, right? Okay, I'm missing something. Oh. Right. Return. Don't know. It should work. Can I run it? Expected 1 on the first mismatch. We have 1. Oh. Oh. These are different errors, while missing parameter B. I guess for some reason it's not seeing it as a procedure. It's not seeing it as an operator. It sees it as a procedure for some reason. Don't know why. Don't know why. Doesn't matter now. It's supposed to be an operator, so it's... I mean, I know it's possible to define things that way, I think. Or maybe I'm 100% wrong. I don't know. I know that we could just do this to make it an actual procedure, and then we can just do this. Okay? And this should work. Comma, I believe. Oh no, because it's an echo, so we need to do this. Okay? And now it works. Whatever, it can do weird stuff. With macros, it can do even more crazy stuff. Yeah. I mean, I have echo here, so the problem is that I could do this if I define it as echo here. Save. Or not. Whatever. I don't know if this thing is running. Whatever. We're really going far off the road. But yeah, you can do whatever stuff you want. Like, really? And we do a dot because we didn't define those, and we could get rid of those. Just crazy stuff. Yep, let's move on. Alrighty. Next one. Keywords as identifiers. If a keyword is enclosed in backticks and loses its keyword property and becomes an ordinary identifier. Examples. Var is hello stropping. I guess somebody's surname. So basically we declared a variable named var, but you will always need to use it with those backticks from now on. I don't know why, but there's that. Type. Object is object, and it has variable type. Okay. And the same thing with object here, of object where the variable type is 9, and we can just make it more convoluted. Variable var is 42, let is 8, var plus let. You know, the backticks give it away, so it's not the worst. Okay? And now we're gonna move on to another interesting thing. String literals. Terminal symbol in the grammar is string literal. Okay? String literals can be delimited by matching double quotes and can contain the following escape sequences. So we have, double quotes and all the fun stuff. Platform specific new line, which is interesting. It's just gonna insert the one that you want. There's no n. Line feed. Oh, line feed is just n. Okay, so this will be preferred if you want to make it multi-platform. Interesting. And R is for character return, N is for line feed, F is for form feed, whatever that is, tabulator, vertical tabulator, never heard of that one. We escape backslashes the standard way, the same with quotation marks and apostrophes, and then this and 0 to 9. Character with a decimal value D. All decimal digits directly following are used for the character. Oh, okay, so we could just make slash and just a bunch of numbers to delimit some kind of code for a character, I guess from 0 to 127. Alert, backspace, I guess all the old terminal stuff. And characters with hex values. Okay, and the Unicode characters can be defined in a similar way. So this is, all common stuff. Strings and Nim may contain any 8-bit value, even embedded zeros. However, some operations may interpret the first binary 0 as a terminator. Okay. Triple quoted string literals. Terminal symbol and the grammar. Triple string literal. String literals can also be delimited by 3 double quotes. Okay. Literals in this form may run for several lines, may contain regular double quotes, and do not interpret any escape sequences. Oh, interesting. For convenience, when the opening triple quote is followed by a new line, there may be white space between the opening and the new line. The new line and the preceding white space is not included in the string. That's awesome. The ending of the string literal is defined by the pattern, quote, 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 and more quotes? Oh, okay. So something like this will be basically a long string of quotes that's being like this, so that we have an opening one and the closing one here. Therefore, we can have something of this sort. Makes sense. What about, so let's try that too. Now, grab all this code, remove it, echo this thing, right? When we echo it, we just have this. Can we do one extra one? Because it will be double quoted, right? And run it. Yeah, we have double quoted. Okay, that's great. Makes sense. Okay. Raw string literals. There are also raw string literals that are preceded with the letter R, or capital R, and are delimited by matching double quotes, just like ordinary string literals, and do not interpret the escape sequences. This is especially convenient for regular expressions or Windows paths. Yep, see you later. So are delimited by matching double quotes. Okay. They do not interpret escape sequences. Okay. This is especially convenient for regular expressions or Windows paths. So we just have normal path, but all those, this would be normally converted into a tabulator, for example, right? So by adding R here, we just make it's raw string, so this won't be escaped. Cool. To produce a single quote within a raw string literal, it has to be doubled. Okay, so just an extra way to escape stuff. Makes sense. Okay, so then this raw string literal opens here, ends here, because double quote is just escaped into a single quote. So this is not possible with this notation because the 3 leading quotes produce a triple quoted string literal. The triple quote string literal with R in front of it is the same as normal, since triple quoted string literals do not interpret escape sequences either. Okay, so you actually could use that. Good to know. It all makes sense. Okay, and this is where the crazy stuff again happens. Generalized raw string literals. Terminal symbols in the grammar generalized string literal and generalized triple string literal. These are quite a mouthfuls. They construct identifier and then quotes, and inside of that we have string literal. Without white space between the identifier and the opening quotation mark is the generalized raw string literal. It is a shortcut for the construct identifier or string literal. So it denotes a routine call with a raw string literal as its only argument. Generalized raw string literals are especially convenient for embedding many languages directly to Nim. For example, regular expressions. So the construct identifier quote 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 string literal quote 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 exists too. It is also a shortcut for this. Okay. How do you define them? My question is, can we define it? I think we went over something similar before. Maybe it's just a normal proc or something. Let's see that we're gonna do proc and we're gonna call it double and it will be text string, okay? And return string. And we just return this. Okay. Echo double hello. And there's no space, right? Save it and we'll run it. Okay, that's good, but this is no different than just calling a proc, right? So what if we're gonna do /n? That will print in multiple lines, I presume. Yeah. Hello, hello. There we go. But if I'm gonna do this, it should take contents of this as a raw string, I believe. There you go. A raw string, that means that /n hasn't been escaped. Just a difference of having that one extra space. Okay? But what that means is that we could easily make something like SQL, and you put your stuff here, and probably a bunch of other stuff. Something tells me there's more to it. Because I recall seeing something at some point where we could just probably do some of that. Or maybe you need to do it yourself. And var a is this. I don't know. I'm sure there's a way to use it. Just with those single letters, it was already useful. So maybe there's some, something more interesting for that. Character literals. Character literals are enclosed in single quotes. and can contain the same escape sequences as strings, with one exception: the platform-dependent new line, P, is not allowed as it may be wider than one character. Oh, that's true. For Windows is CRLF, whatever. Caret return and line feed. Here are the valid escape sequences for character literals. Okay, just a little bit less. Other than that, mostly the same thing. Sure. A character is not a Unicode character, but a single byte. Rationale: it enables the efficient support of array, character, integer, whatever, or set of characters. The rune type can represent any Unicode character. Rune is declared in the Unicode module. We use that in our countdown thing to manage displaying Unicode characters in the terminal. A character literal that does not end in a single quote is interpreted as a quote. Huh? If there is a preceding backtick token, there must be no white space between the preceding backtick token and the character literal. Wait a moment. A character literal that does not end in a tick is interpreted as tick. If there is a preceding backtick token, if. Okay. There must be no white space between the preceding backtick token and the character literal. This special case ensures that declaration like procedure, backtick, apostrophe custom literal as string is valid. What? Oh, it doesn't need to start with a character because it starts with a backtick, and that makes it special. What for? Procedure, custom literal, yeah, is the same as procedure. Oh, we can. Oh, we can actually escape within here. That's nuts. Wow. That means you could have N as an escape character? Gosh, this is nuts. And custom numeric literals. There we go. This is getting crazier and crazier. Numeric literals have the form, and this is again this whole representation. This is just to define numbers, right? This is what makes me not want to make my own programming language, because you need to deal with all those rules. Not great, not fun, at least for me. As can be seen in the productions, numeric literals can contain underscores for readability. Integer and floating point literals may be given in decimal. No prefix, binary, prefix OB, octal, prefix OO, and hexadecimal prefix OX notation. Welcome back. Confidence. Okay, we've got a second viewer. Awesome. We've got a crowd. Yeah, we're going through the manual. It's not as bad as I expected. Other than just encountering crazy stuff that's possible with the language. The fact that the unary minus in a number literal like -1 is considered to be part of the literal is a late addition to the language. Oh, the rationale is that an expression -128 and 8 should be valid, and without this special case, this would be impossible. Like minus 128 is not a valid int 8 value. Only minus 128 is? Huh? Okay. For the unary minus rule, there are further restrictions that are not covered in the formal grammar. For the whatever dash to be part of the numeral literal, the immediately preceding character has to be in the set of space, tabulator, new line. Oh, new line, return, comma. This set was designed to cover most cases in a natural manner. This doesn't sound very natural. Confidence says, Nim is so attractive to me since I love Python a lot, but I don't have any project that needs Nim for now. TypeScript has me by the throat right now. I learned to program in Python and Django for the web, but I have fully switched to Node and Vue.js for work. If you're dealing with Node and Vue.js particularly, it's good. Vue.js is awesome. It's like best framework so far for me, in my opinion. It's pleasant to work with, not too crazy. But yeah, TypeScript can be tough at points. Often I just switch, you know what, screw that. For a small project, I'm going with JavaScript because I can manage. For large projects, sure, you need to have TypeScript or gonna have different set of problems. In the following examples, the -1 is a single token. Echo, -1. Echo this. Oh wait, this is middle preceding character has to be in. Oh, so whatever needs to be before the dash. Either the space or parentheses or this guy. Or a comma. Okay, that makes more sense instead of being after. Awesome. And this works as well. Cool. In the following examples, the -1 is parsed as two separate tokens, as a dash and as one. So dash will be in this case an operator. So here we just have a character, so that makes it into minus. We have a closing bracket, so that's why. Same thing here, and this is a quotation mark. Okay, makes sense. All of this suddenly makes much more sense. The suffix starting with an apostrophe is called a type suffix. Oh, this is where crazy stuff is happening, because you can make your own. Literals without a type suffix are of an integer type, unless the literal contains the dot or e, in which case is of type float. This integer type is int if the literal is in the range of low and high of integer. Otherwise, it is int64. For notational convenience, the apostrophe of a type suffix is optional and is not if it is not ambiguous. Only hexadecimal floating point literals with the type suffix can be ambiguous. So we basically, when we specify a value, we can add this kind of thing at the end to specify what kind of type it is, without the need to specify the type, like, specifically. So yeah, this is awesome. And I guess U is just uint, D is for double, F is for float, and then we have those separately. Makes sense. Floating point literals may also be in binary, octal, or hexadecimal notation. Seriously. I guess if you want to be as precise as possible, makes sense. Huh, never thought about doing that. I guess there could be a need for that, for a very specific number. Literals must match the data type. For example, 333 as int 8 is an invalid literal. Oh, because it's invalid because this should be at most 127 because it's integer, not even U integer. Non-base 10 literals are used mainly for flags and bit patterns representations, therefore the checking is done on bit width, not on value range. Okay, I'll ignore that. Custom numeric literals. This is where the fun begins. Oh yeah. If the suffix is not predefined, then the suffix is assumed to be a call to a procedure, template, macro, or other callable identifier that is passed the string containing the literal. This callable identifier needs to be declared with a special apostrophe prefix. Welcome back, CPN. You're in for the good part, for custom numeric literals. So we can basically have a type U4, which is a distinct uint8. A 4-bit unsigned integer, aka nibble. Okay, so we can define a proc that starts with an apostrophe U4. Okay, that takes a string and returns the U4, which returns that specific type. So the leading apostrophe is required. And therefore, we could make that result is parse this integer and I guess 0 some stuff and convert it to U4. And therefore, we can just define a variable by x is 5 and that new proc of ours to convert this string 5 into actual value. The good thing is all this string stuff is happening during compilation time, not during runtime. Yeah, because that's how we define, you can define other value that way. So yeah, that's nuts. But that means we could probably define our own weird one, right? Is that possible? We don't need to have anything specific, right? So we can just do proc apostrophe what could we count in? What will be a fun thing to count stuff in? Hot dog? Right? And that we'll take as a string and return a hot dog. So we can say that type a hot dog is an object that basically has length, right? And now we integer. So we could take, we could basically take that, let length is parse int. Do we need anything for parse int? I guess string utilities. Okay. Error type. Really? Oh. Lowercase. Okay, so that will be an integer. And return hot dog without length. Therefore, we could say let, and we could do, 12 apostrophe hot dog, right? And this is considered a number literal. Go figure. If you really want to, you can do that. Echo hot dog length. And does it run? It does. 12. So, I could see it as, let's say you want to have... this will be actually interesting. Because another interesting thing will be that, again, unit conversions. This is like one example that I kind of like. Let's say that we have types, and let's say inch, okay? An inch will be a float, okay? It needs to be a float. And then we have feet, which is float, and then we have meter and centimeter. All of those will be floats, just various lengths, okay? But let's make them all distinct, okay? Therefore, you won't be able to do operations that you would do normally on float and all that stuff. So you can't mix inches with feet and all that stuff. So then we could define a proc in that takes a string and returns inches. Okay? It just parses the float, and return. Really? Just do that. Okay. Dot inch. Therefore, we could basically say that, var, I don't know, screen diagonal is 100.0 apostrophe inch. Wait, in, I presume. Okay, there we go. Ignore the weird little bell. It just, for some reason, the Nim suggest marks everything that could potentially throw an error, like all the calls, which is weird, annoying thing. You can see bells everywhere. But we just have an inch, so we could basically the same thing, proc feet, okay, and then we have meter and centimeter, okay. So we can just say var, let's say, whatever, height is 180 centimeters. And it kind of looks like a normal value. We just have that extra tick in there. And then you can define, of course, various things for converting. This is kind of fun. I can see it being used and having some kind of purpose. If you're writing some kind of, if you have a code base that specifically deals with, various units and you need to make sure that things are compatible and whatnot, this is fun. This would save so much time instead of doing dot centimeter, right? Because there's nothing stopping it from that. And you just converted it. But hey, there you go. Sure. I don't mind that. Too bad you can define it for some other stuff. This is only for numbers, right? Can I do this? Save? No, only for numbers. All right, let's move on. So we went through that. More formally, a custom numeric literal 1 to 3 custom is transformed into R1 to 3. So raw string dot custom. Okay, that makes sense. In the parsing step, there is no AST node kind that corresponds to this transformation. Okay, so it just literally replaces it with that, and that's it. The transformation naturally handles the case that additional parameters are passed to the callee. Really? So if, again, that's that type procedure with more information. Okay, is that thing and whatever more data would be used for. Oh, wow. This is getting weirder. Sure. Oh, wow. This is very, very weird. Custom numeric literals are converted by the grammar rule named custom numeric literal. A custom numeric literal is a single token. Okay. All right, let's get to even weirder stuff. Operators. Nim allows user-defined operators. An operator is any combination of the following characters. Oh, that's why I couldn't just name an operator as text, I think. Too bad. Yeah, they need to be made out of those characters. The grammar uses... Oh, let me just get back to normal. Okay. The grammar uses the terminal OPR as operator to refer to operator symbols as defined here. These keywords are also operators, and or not all those are operators. I guess we can't override them. Or we could probably... That's interesting. So dot equals colon and double colon are not available as general operators. They're used for other notational purposes. Okay. And start colon is a special case treated as the two tokens, star and colon, to support variable v that is public, and then we define type t. Okay, that's the specific reason for it. And the not keyword is always a unary operator. A not b is parsed as a not b. Okay, not as a and then not and then b. Makes sense. Doesn't mean that I can define or, like my own version of or. Oh, there are Unicode operators. We'll get there in a second. Doesn't mean I can define or. Proc or A is centimeter and B is foot or feet. Yeah. And return meter. Okay. Return whatever that means. A.float divided by 100 plus B.float times this. And we just grab the whole thing. Dot meter. Whoops. And we just define that. So we should be able to... Let's make this inch, okay? So var something is height or screen diagonal. Okay. Possible. Doesn't make any sense, but it's possible. Gosh, I for some reason, I absolutely love that you can make things that don't make any sense. Having C# background where everything is really rigid and you can only do things correctly, this is absolutely awesome. It's like you're breaking out of jail. You can do whatever. Yeah. Love it. Okay, so let's take things a little bit further, make it a little bit more crazy. And let's look into, we know that all those symbols are usable as operators. So we could just do, I don't know, an operator that instead of or, it's this, star. What else is there available? This, that, and dash at. Okay. We just do that, paste it here, save it, and it's all fine. You can do that. So the inch and centimeters are not built-in types. I just define them here, that these are distinct floats. And distinct means that, it's not compatible with other floats. So if I have var sum inch is, let's say, 100.5 dot, what just happened? 100.0 and we'll just make it into inch. Okay, we create a new inch. And we can do something with feet. I can't do some inch is some feet. It will basically say, hey, these are not compatible. Even though in the background there are floats, you can't do that. I wonder if I can just do inch. Yeah, I could force it explicit if I wanted, but not. And then I define those custom number literals that convert into those specific numbers so that I can actually use them as if they were types. So you can just straight up do that. It's nuts. Yeah. Yeah, that's that. Is tilde as possible? Yeah. Okay, so we could just do this and have that as an operator. Yeah, that works. Go figure. Whatever you want. And we can override all of those, which is absolutely awesome. Even from can be overridden. Yeah. And then we go to Unicode operators. These Unicode operators are also part as operators. Okay? So we can define all those little fancy little characters as part of an operator. So we could just make it into this. Okay? So it looks a little bit more mathematical. Possible. You can do combination of all of them. I really like that we have, like for multiplication, we could do that, or that one, or whatever you want, really. And the fun fact is that these can be just parts of names of things, of procedures, or some other stuff. So yeah, crazy. And the slice operator, ... takes precedence over other tokens that contain a dot. Are 3 tokens. This and that, not the 2 tokens. Okay. Doesn't mean we can override the ... operator? Is that really possible? Save? Yes, it's possible. Great. The only thing is that we can't override a single dot, or equals, or colons, or double colons. I guess that means we could have triple colon? 1, 2, 3. 1, 2, 3. Yes, that means we can have triple colon. Can you provide custom range to these types? Definitely, because we can define an operator ... So we could make that possible. 100%. How the hell did ranges go? Ranges they're like generic type of range. I don't remember what it was exactly. But yeah, you could define that. Let's do custom range for centimeters, okay? So we'll just do this takes centimeter and returns gosh, what was the thing for the range? What is the type of the type returned by the range operator? For example, 5 ... 45. It wasn't like straight up range, it was something with a letter. In the meantime, I could probably just check, right? Var x is 5 ... 45. H slice, and we have those 2. So we could just copy this and say that it returns a slice of 2 centimeters, or even could have 2 different things. And one that try to call, you can construct it in some way, yeah, but it's possible. It's weird, but it's possible. Can you just say return h slice like this? You can probably defined them or something. Open array. I'm sure you can define it somehow. Yeah. Just never delved into that. We would need to look at the type. Yeah. Manual. Okay. Unicode operators can be combined with a non-Unicode operator symbols. The usual precedence extensions then apply. For example, this is an assignment-like operator, just like star equals is. No Unicode normalization step is performed. Oh, the assignment operators. How does that work? I have no idea how that works. Assign operators. So I should be able to, wait, equals is a part of a symbol. So in theory, I could make a proc like this. And then A is B dot float times this. Sure, and then convert the whole thing to centimeters. Okay. How do I use it? Because the way I can see it is that I would need to say, we need to take A, which is centimeters, which will be height. So we do height, screen diagonal. Oh, we can do that, and it takes whatever's on the left. But I don't know if that equals is in any way special here. Because what's stopping us from doing, I don't know, this? Right? It still works. It still takes this. Don't know what's the difference. What the difference is. Probably there's something behind the scenes that's happening. I don't know. It's not explained here. Oh, Taras Morzepa said hello at some point on Twitch. Welcome back. Long time no see. I'm back to reading documentation. Other tokens. The following strings denote other tokens. So we have backticks, parentheses, curly brackets, square brackets. Whatever these are used for, that's interesting. These are for pragmas, and no idea what that is. And additionally, we have a smiley face. Interesting. I haven't seen those used before, so that's new. The slice operator takes precedence over those. Okay, we read that. Cool. All right. Taras Marzapa says, what is that about? Well, we're going through the Nim language manual that explains all the intricacies of how the language works itself. And there's some crazy stuff here. Absolutely nuts. Taras Marzapa says, I have recently finished key milestone in my command line tool stacks. What is that milestone? Because I saw that you were pushing some stuff, and that's awesome. Maybe you can elaborate a little bit. In the meantime, actually got to the point of syntax. Wow. We're storming through this. So let's read about syntax. That sounds interesting. Years ago, I would have never thought that I'll be excited to see, oh, there's a syntax of the language. I'm going to read the manual. This section lists Nim's standard syntax. How the parser handles the indentation is already described in the lexical analysis section. Yeah, we went through that. Nim allows user-definable operators. Binary operators have 11 levels of precedence. Oh no, that part. Oh no. You know, what is happening before, like plus is before this and that. There's a lot of rules for that. Associativity. Binary operators whose first character is this little dash thing are right associative. All other binary operators are left associative. Oh. So if we have proc, which is this dash slash, we give it two numbers, x and y, a right associative division operator. So we just do result is x slash y. So normally we would probably calculate this on the left and then result of this into that, right? So right here, we would have 12 by 4 equals 3, and then this 3 that resulted would divide by 8. So here will be the opposite. We'll probably do, because we have the first operator, instead of doing stuff on the left, it does stuff on the right first. Oh, that messes things up. So we do 4 by 8 first, which is half. And then we take 12 divided by half. Oh dear, which will be 24. That is vastly different. Oh wow. So every operator that would define that way will be that weight. Let's try that. Let's define our own operator. But let's first read what Taras Marzepa has to say. My log command is finally working as I expected, and I hope it is without many bugs. Right now, I'm running it on 1 million automatically generated end-to-end tests. On those tests, I worked for 3 months of after-work hours alone. I started to work in November, and 4th of July, I was done. Nice. Okay, you started working on this project. Wow, okay. So the log command, I guess it will basically log all the actions that you took in your repo or something. That's interesting. Maybe we can look it up. GitHub.com. Someone tells me it'll be right here. You're not right here. Stacks, was it the name? I had it liked. Let me just read. Come on, why isn't it showing up? I have it starred. Need more stars. Come on. Taras. Mazepa, not. Why am I putting R in your thing? Yeah. It's not a great search. There we go. There you go. 10 hours ago, diagrams. 6 hours ago. Okay. So, do we have info on the log here yet? We got the log. Outputs tree-like structure of your branches. Oh, okay. I see. That's interesting. So you've been busy. That's good to hear. And you're slowly getting stars. So for everyone who wants to support Taras. Here it is. So what is this project about? Stacks is a tool that will help you a bit with day-to-day stacks-like workflow. Main purpose is to make it easier to create smaller PRs and reduce amount of energy other people need to review them. So it would be nice to probably have a link about stacks like Git workflow, because I personally don't know what that is. Although I might have heard a podcast about it, I'm just not aware of it probably. Explain what, come on, is stacks like Git workflow. It's an approach to managing branches and merging code that aims to simplify collaboration and reduce merge conflicts. Feature branches, okay. Trunk-based development, okay. Frequent integrations, small focus commits, automated testing, quick conflict resolution. Immediately to keep the... Okay, so this is like just your regular healthy Git workflow. Okay, makes sense. There's a website, stacking.dev. Stack PR, stack diffs, stack changes. Okay, that makes more sense. Code review, more time. You can stack waiting for hours, even years before you can merge. Years, jeez. Poor people. Okay. Stacking allows you to skip. Go to main, feature A. Bam, bam, bam. With stacking, you don't have to do that. Instead, you put your server changes up for review. Create new dependent branch and continue working. Okay, you just create pull requests from there. You continue. Oh yeah, I did that a few times. Yep. Because you expect that this is gonna get merged in, so just continue working instead of waiting. Absolutely. Okay, so this is basically a tool to just keep doing that automatically, rather than you just creating new branches from those branches. But it's just, okay, I guess I'm used to one command. I guess it simplifies, because you have like the whole tools for viewing more stuff, I presume. So now that we have some context for it, so Stacks Doctor will help you set up everything Stack needs for working. Okay. And we basically have commands. Commit creates branch, commits current changes with the same name as the branch, and pushes. Okay, so you basically commit everything every time you create a new thing. Oh, okay. Huh. That's different. And then we have amends to the current commit, and force pushes branch, okay. And delete gone branches. It deletes local branches with gone remotes, useful when you are using stacks commit, which pushes all the branches. So once they are merged and deleted from the remote, you can clean up local branches. Interesting. And pull, switching to main branch, pull all the changes, deleting gone branches, and switches to original branch, okay. And log outputs tree-like structure branches. Interesting. And CPN says, I'm at a CLI password manager and lost most of my passwords. Oh, that's not great. That sounds like a not fun story. Yeah, that's one tool that I wouldn't want to make actually my own password manager, because it feels like, yeah, I wouldn't trust myself to make it safe enough. All right, awesome, Taras, that you keep working on that. That's one, like, super awesome. There are too many abandoned projects, I'd say. I'll need to learn more about stacks, see if that works. I mean, I don't have much stuff that I collaborate on with people, so I don't need it that much, but I guess in a little bit more busy environment, that could work. Interesting. I remember listening to some kind of podcasts. Somebody made like whole tool that expands on GitHub with comments and everything, where you can just keep going, keep adding, and then you have like one way to review a bunch of stuff. But gosh, that was a long time ago. So the next command is rebase trees of branches with stacks. Okay, so that will be a lot of Git commands happening in the background, I presume. CPN says that he learned a lesson. He or she, I actually don't know, might learn a lesson that you should test your password manager before actually using it. Yep, made similar mistakes before. Okay, let's get back to the Nim Manual. So we learned that with those we can just invert associativity. So that means that we can make our own. Whoa, I wonder if that's possible. Oh gosh, another stupid idea. Let's get rid of all of that. We don't need it right now. Proc. And we do this equals a var, a, which will be integer, and b, which will be var integer. And is, oh, that's probably not gonna work. B is a. Oh, that's gonna work. So we have var a is 5, var b is 10, and we can say a, this b. That means that b will take a value of a. So b will be 5. So both should be 5. Oh, that would mess with your brain. Yep, that's possible. Why not? Oh, this is nuts. You can do just so weird things. And the thing is that you can combine it within other ones. So, oh, let's not go there because this is nuts. Oh yeah, Nim is fun. Yeah. I mean, you have so many little tools to build your own little languages or whatever. But the thing is that as long as you need to work on something with other people, you don't want to use those features because nobody will know what your code means. Unless you're really aiming for job security, then you just go for it. But then you will need to build your own AI to understand your own code. Okay, so precedence. Unary operators always bind stronger than any binary operators. Okay, so something like this will take precedence over this. Okay, unary as in takes one argument. All right. So this is basically like wrapped in parentheses and then that, and not the other way around. If a unary operator's first character is at, it is a sigil-like operator, which binds stronger than a primary suffix. Oh, look at that. So the at, because normally, if I would normally do something like echo, so let's make a type car, okay? It's object and sure, make and model, okay? And we'll just make the whatever, some kind of car. Var Rivian is, I don't know if that's the real model, but whatever. So we can do echo. I mean, echo does it on its own, right? But you could do Rivian dot make, right? And what that means when we run it, I'll just get rid of everything else. Well, that means that we're gonna print just the make, right? Just says Rivian. Because this whole thing is evaluated first. It's just as if we had it like this. But if we're gonna make proc, and we're just gonna start with @ symbol, and whatever, make the $sign or something. And it takes the car and returns a string. So what we can do here is that it will basically make the car.make is Ford. Okay. Let's just make var new car is car, and just so that we have a variable, and return new car. Okay. Yeah, sure. Return a car. So that means that we can just do this, of course, like that. And this suddenly won't be applied to the whole thing, but will be applied just to the immediate thing. It takes precedence even before that. Therefore, when we run it, we'll actually print out, not Rivian, we'll print out Ford, because this got replaced with the other one. Huh. More not stuff, just override all the rules. Yep, there you go, Ford. This is nuts. So yeah, it's sigil-like operator. So at x.abc is parsed as this.abc, whereas just that will be parsed as the whole thing. Yeah, exactly. For binary operators that are not keywords, the precedence is determined by the following rules. And this is where the crazy start is happening. Operators ending in either dash, whatever, those 3 different arrows are called arrow-like and have the lowest precedence of all operators. So they will be evaluated last. Okay? What were they thinking when designing the language? I don't know. A lot of stuff is absolutely awesome, and this is, I guess, just to allow for things like macros. And I presume, a lot of this stuff, like this stuff you will never use unless you have some very concrete reason to do that, to allow for some edge cases. But things like with those arrows, right? The thing is that many languages, like in JavaScript, you have arrow functions, right? That operator is a part of the language that's embedded in it, and therefore you can't do anything with that. You can't change what arrow does, okay? The thing about Nim is that a lot of it, like whenever you're using the language, half of the operators and other things are defined within Nim. It's just normal thing. So I can just make my own arrow operator. There's nothing stopping me from that. They're used for macros. That's how you have arrow functions actually defined as, macros. So it's not a language feature, it's just macro built with the language. And therefore you can just make your own versions of everything. You want an arrow to the right, at least in this case. You can make your own implementation of channels or something. We can do that. Nothing is stopping you from that. So that's the thing. It's very extensible. You can remake big chunks of the language. And those arrows being that way, because they look that way, whatever they end with this, it will basically mean that they have lower precedence just to help you out so that it makes sense for the operator to work that way. So if I want to, let's say, make an operator that proc, let's say this will be just an arrow, right? Or maybe an extra long arrow, right? And it's gonna take A as a what would it be? String. Wait. A as sure string, and B would be in this case a proc that takes a string and returns an void. Okay, just like that. So this way, I believe I defined something. Is that possible? I am not 100% sure now. But it's an operator that on the left takes a string and on the right passes that string to something. I don't know what the reason would be for that, but it should be possible, I think. And therefore, how it would work, we just take B and give it A. Okay? Save. Something like this. Oh, whatever, value. Okay. There we go. So that means that I should be able to do this and then an arrow to echo, I believe. Type mismatch. It doesn't return anything, should call it. Oh, because echo isn't like that. Okay. Sure. This will need to be a proc that takes value string and calls echo. There we go. It's totally pointless, but you can do shenanigans of that sort. So suddenly, if I would have something happening here like this and concatenate it with Wallala or something, right? Space Wallala. And we have something on the right. What will happen is that this has the lowest possible precedence. Therefore, everything here will be evaluated first, and everything on the right will be evaluated first, and only after that, this will happen, which makes sense for an arrow. So, reading about it is like, oh my gosh, yet another rule, but it kind of makes sense. So, yeah, it's just, have you ever read formal specification for JavaScript? What rules are there? As far as I know, it's just absolutely nuts, all the edge cases. Well, here everything is extremely generic. So 2 extremes, I'd say. If the operator ends with an equals and its first character is none of those, oh wow, okay. It is an assignment operator which has the second lowest precedence. Okay. Otherwise, precedence is determined by the first character. Oh, so these here are, I guess, so that... And the first character is none of those. Oh, so it starts with that, ends with that. Oh my gosh, my head hurts. This makes JS sane language. I mean, we're going into the weeds, that's why. So yeah, the highest precedence to the lowest precedence. It's a long time since I saw something like that. This is what you usually see when you read a book about a language and they tell you what the order is. At least maybe in old books. I don't know if new books still do that. And you have all those things. What happens before what? And believe me, JavaScript has all that. Let's see if chat can help us with something like that. Where do I have it? I lost it. Yes, I lost it. So let's go to Claude and please make a table describing operator precedence order in JavaScript. There should be something about it. Okay, there you go. All the operators. And there's a lot of them, right? There you go. Nice 19 levels of precedence. You have associativity, left to right, left to right. This one is right to left, the new. It's a unary one and all that stuff. So it all exists within JavaScript. It's just you don't read about it really explicitly because it all kind of makes sense because we're used to how languages work and it makes sense. If you end up doing something weird, like, oh, okay, when you start getting weird, doing weird stuff, that's where it all matters. Like you can see the conditional, the ternary operator has higher precedence than nullish coalescing, or I don't know which one is up or down or whatever. I guess this is the most important one. No, this is the most important one, grouping. Yeah. Well, these will be the least important ones. The ones evaluated the latest. Yeah. Go figure. Whether an operator is used as a prefix operator is also affected by preceding whitespace. Okay, this parsing change was introduced in the version 0.13.0. So this is parsed. Oh yeah, because with how we're calling functions that we can skip things. So this is parsed as this. Spacing also determines whether a comma b is parsed as an argument list of a call or whether it is parsed as a tuple constructor. So this will be echo with values of 1 and 2, while this will be echo with the value of this tuple. Because if we have that space here, that means that we are already calling it in a parentheses less fashion. Okay. And then we've got dot-like operators. Dot-like operators. There's plural here. Terminal symbol in the grammar is dot-like operator. Dot-like operators are operators starting with a dot, but not with dot dot. For example, dot question mark. They have the same precedence as dot, so that a dot question mark b dot c is parsed as, you read from left to right, okay? And that means we can have our own dot operators that do extra stuff in between, which is awesome again. Yeah. I wonder what it feels like to describe your own. Yeah, what if we have an operator like dot, but it kind of logs everything in between? So let's do proc, and let's make it dot exclamation mark. It takes, and let's say that it takes TA and TB. That's not gonna be easy. Huh. How do you define something like that? Okay, this is not easy because I don't know how to define the whatever's inside, right? Because we want to return the type of TB. I mean, the whole idea is that we return a.b, right? So I don't know how to describe this argument. I really don't know. Okay, I already give up. This is past my skill level in the Nim language. Okay, let's move on to grammar. The grammar's start symbol is module. Can you define an operator as a template? Yeah, if we would define it as an object, we wouldn't be able to call it because can you call dot with an object? I don't think so. This needs to be like identifier or something. Is there a definition of a dot symbol or something? Gosh, I want to see if there's a definition somewhere. But I don't think so. In theory, we could just, where's the browser? Let's say we open up the standard library in a new tab. Is there like a, let's click source, because this is the standard library, right? Nim, the whole Nim, the whole repository. We can press period to go to the VS Code of that repository. And let's see if the dot operator is defined in some way. But as far as I know, the language doesn't allow for just that one to be defined, right? Ctrl-Shift-F, backtick dot backtick. It's all in markdown files. Pragmas.nim, all descriptors. Yeah, we won't have it defined because it's not allowed as far as I know. Yeah, we can borrow the operator, but that's pretty much it. Yep. Yeah. That's that. Don't know how to define the type of that. But can you define a template? You could define a template like this, which takes the type A. Not even make it generic. Oh gosh, this is painful. How the hell was the typeless thing? Untyped be untyped returns untyped. And we just do echo a.b and return a.b. Can we use that? So yeah, type car. Sure. Let car one is, there we go, Honda Civic. Sure. So if I'll do discard car one dot make, okay, it just should print nothing. Okay, that worked. Nothing. Can I make this and use it as an operator? No. Return not allowed here. Oh, because we don't have it, right? Now, yeah, dot-like operators we parse differently. With nim preview dot-like operators, return not allowed here. Yeah. Oh. We don't do that because template shouldn't have return. Yeah. Nope. This will need to be macro and a bunch of stuff. We're wasting time with stuff that I have no idea about. Sorry about that. Okay, let's move on a little bit more. The grammar start symbol is module. We'll ignore the grammar because that's the grammar of the language, and that is a little bit longish, but it'll be very useful if you want to, if you want to make a parser. Order of evaluation. Oh, I hate this topic. Order of evaluation is strictly left to right, inside out, as it is typical for most other imperative programming languages. So you have variable s, which is empty string. You have procedure p, that takes an integer and returns an integer. So string add the string value of the integer and return the integer. Okay. So yeah, and discard this thing. So we basically evaluate whatever's inside here, do that, inside here, and that. Yeah, left to right. So left to right. unless you define the operator that's flips things. Yeah. Okay, makes sense. And do assert and all that stuff. Assignments are not special. The left-hand side expression is evaluated before the right-hand side. Okay? Yep, that's the assignment. And we have all that stuff here. Sure. And of course, unless we define our own that we flip things. But by default, all assignments are just like you would expect in any other language. So no big deal here. And doesn't look, we have the array operator, we assign to it from, right to left, all that stuff. Rationale. Consistency with overloaded assignment or assignment-like operators, A equals B, can be read as perform some copy A, B. Okay. However, the concept of order of evaluation is only applicable after the code was normalized. The normalization involves template expansion and argument reordering that have been passed to name parameters. Okay. Order is B before A due to template expansion semantics. Oh yeah, because swap args will just flip stuff behind the scenes, and yeah, swap arguments, it will swap the left side and the right side and all that stuff. Sure. Makes sense. This is very easier to implement than hypothetical alternatives. I'll ignore that for now. And let's do one more thing today, at least. Yeah. The fun part again, constants and constant expressions, because this is another little spot where the Nim language shines a little bit. A constant is a symbol that is bound to the value of a constant expression. Constant expressions are restricted to depend only on the following categories of values and operations, because these are either built into the language or were declared and evaluated before semantic analysis of the constant expression. So you can have literals, built-in operators, previously declared constants and compile time variables, previously declared macros and templates, previously declared procedures that have no side effects beyond possibly modifying compile time variables. Okay? So a constant expression can contain code blocks that may internally use all Nim features supported at compile time, as detailed in the next section below. Within such a code block, it is possible to declare variables and then later read and update them, or declare variables and pass them to procedures that modify them. However, the code in such a block must still adhere to the restrictions listed above for referencing values and operations outside the block. The ability to access and modify compile time variables adds flexibility to constant expressions that may be surprising to those coming from other statically typed languages. For example, the following code echoes the beginning of the Fibonacci series at compile time. This is a demonstration of flexibility in defining constants, not a recommended style of solving this problem. Yes, so I recall this is a fun one. So let's look at that, because this is powerful. So we import string format, okay. We declare a variable, Fibonacci n, okay, I guess which number we're at. We mark it as compile time, somehow, and we say it's an integer. So it's a compile time variable. It can change during compile time. Then we had the previous, again, compile time, integer. And previous, I guess we need to remember 2 numbers back to calculate the next number. There we go. And now we define a procedure, next Fibonacci, which will return if the Fibonacci n is less than 2, return Fibonacci n. Otherwise, add the 2 previous ones. Then after that, increase the Fibonacci number, update the previous ones, right? And that's our function. All right. So then we can just do constant F0 is next Fibonacci, and constant F1 is next Fibonacci. So the way it works is that because this is a constant, this needs to be evaluated in compile time. So the moment we're calling this guy, all these will be updated in the background because this needs them. And therefore, all those values will be already pre-assigned during compile time. And then we do constant display Fibonacci, and it will have a value that will evaluate all this code during compilation time. So constant F2, next Fibonacci, var result, format. So string formatting is also compilation time, which is awesome. That's often something skipped where you can't really operate on strings. And the whole loop where we can just keep adding for, a few more times. And then we return that. So this will be assigned to the display Fibonacci, which will be just a text. And therefore, and of course, F0, F1, F2, we took those constants. And then at the end, we use the static keyword, which means that this code will be executed only at compile time and not at runtime, which will just print out during compilation time. And CPN says Zig also has this feature, comp time. I know that Zig has good comp time, but I don't know to what extent. Let's see. Let's see if our expert expert Nim thing can actually maybe convert it or something. Nim expert. Is it possible to implement the following Nim code in Zig programming language? It should all be evaluated during compilation time. Let's see what answer we're gonna get, or if something's gonna make sense. Because I wanted to learn Zig, but then I'm looking like it's just crazy low level, and it's like I don't have a purpose for that. It's like Go version of C++. As far as you know, AI is not very good at Zig. Yeah, I haven't tried any stuff. Yes, it's possible, but there are some differences in how compile time execution is handled. Equivalent implementations. So we import a standard stuff, okay, standard library. Comp time function to calculate Fibonacci numbers. Oh gosh, this is so much more code. Yuck. So function next Fibonacci, and we have comp time and usize. Comp time previous, we need to define those within the function. Look at that. That might be one thing. Already one limitation. I guess we can't define variables that are compilation time. Usize, and then constant result. We just do calculations. That's not a problem. We just calculate stuff, update it, really, whatever dot star is, and return result. Okay. And does it call itself? No. Yeah, I don't know how much that would be. Fibonacci sequence using all this stuff. And then constant, compile time constant containing the Fibonacci. Okay, that makes sense. Generated, so we can call it. But look at that. We can't print it out in compilation time. So this is evaluated compile time. Okay, it will be embedded here. Oh, compile log. Okay. If you want to print it at runtime as well. Okay, so I can see it being possible if it's correct. Yeah, it's like C without the foot guns, exactly. As bit verbose. That's exactly why I didn't want to go with it, relearning it, because it's just too low level for me. I like having, garbage collection in Nim, just straight up. By the way, there's a 1 for calculating Fibonacci's number. Okay. I mean, yeah, you can do recursive stuff, no problem with Nim. You can just do most of the Nim stuff during compilation time. I just wanted to copy that example and play with it because I actually never played too much with compilation time stuff, okay? So let's get back to this example here. Let's copy it. Let's plop it here. Get a little bit smaller and see what happens. Save. And can we run it? Run. There's the Fibonacci sequence printed out, okay? That's the compilation time. So now I could do ls. And you can see that we have this entry.exe. That's the program we just compiled. If I'm gonna do entry.exe, we just run the program, but it didn't print anything because it doesn't have a single instruction what to do during runtime. I wonder if we could do non-static and actually print those out one by one to see if they are actually, I mean, those variables, if they are still, they should be accessible during this stuff, right? So echo, and we have, let's do fib n is this and that, and then echo f0, 1, and I don't think we have anything else to print out, right? We have displayed Fibonacci also as a constant. Display Fibonacci, and when we compile it and run it, oh, results. What? 14. Oh, I added it by accident, sorry. Okay, so first we have whatever was printed out during compilation time. And then we just run those, and look at that. This is different. So during compilation time, we were evaluating those, and they should be in various states, right? Because they were increasing, and we increased probably to like 12 or something. While during runtime, because these are variables, they're not constants, they didn't have any values saved. They were basically zeroed, 0, 0, 0. While constants stay constants, and we were able to print them out. So again, we can just go over here and run it again, and now we just have those. So that's very interesting. Those can be used during compilation time, but whatever happens during compilation time, it doesn't have any effect on them because they're variables and not constants. But you can still use them. Interesting. Very interesting, to be honest. Huh. And yeah, this way you can just pre-calculate a lot of stuff and build it for yourself during compilation time, and then your code runs faster. I believe there are whole macros that straight up, create lookup tables for things, so you can pre-calculate things and, have it just, bam, make a constant table out of that. Yeah, I even was doing something where I'm reading glyphs or whatever from a string, decomposing them into glyphs and other stuff, and basically during compilation time, turning complex strings, divide them into glyphs, optimizing everything, and during runtime is already precompiled. It just works. And finally, we have restrictions on compile time execution. Nim code that will be executed at compile time cannot use the following language features. Methods. And methods are specifically things that, for inheritance of objects. They're rarely used in Nim in the first place. Of course, my first project involved them. So that's fine, sure. Closure iterators. So these are specific iterators that I don't remember how they worked. I haven't used them much yet. It's one of those features that, you forget often. The cast operator, because the cast operator is basically the unsafe code running on pointers, where you can cast one pointer of one type into the other. So I guess it makes sense that you don't want to do that during compile time, because you can introduce weird errors. And then you have reference pointer types. Really, no reference types or not reference types at all. And you can't call, foreign functions. You can't call C++ or whatever during compilation time. That kind of sucks. The use of wrappers that use FFI and or cast is also disallowed. Know that these wrappers include the ones in the standard libraries. Some or all of these restrictions are likely to be lifted over time. Sure, maybe in 10 years. Reference pointer types. Really, it's impossible to use them. No way. Oh yeah, because you can't make it a constant, right? Huh. So if I made type Fibonacci data is an object and has n previous and previous, right? So I could make var Fibonacci data, compile time, all that stuff, right? No problem. So wherever we have Fibonacci n, we can just replace it with this dot n, okay? Whenever we have previous, we can just do fib data dot prev. Okay, and then the last one, fib data dot prev. And that should all work. I'll ignore all this stuff. Redefinition of fib data previous declaration here. Oh, duh. Capital F. There we go. We start and it should work. So when I run it, it works. Okay. So what if I'm gonna make it a ref object? Okay. Ooh, attempt to access nil address. Like this. Can I do that? That worked. Really? But that's a reference object. Unless it specifically says just not pointer types. Normal reference objects work. Because this isn't a reference object. And strings and everything. So I guess normal reference objects work. You just can't use pointers. So yeah, if we had Fibonacci data and then we made var fib data pointer, just compile time of pointer Fibonacci data, which is address of this thing. Save. Really? Will that run? What the hell? This might be a little bit outdated. Because I just used pointers within... What the heck? Everywhere. Everywhere I have reference to it. Maybe nearly everywhere. Pointers. Run everything on pointers. Still runs. Are we sure it still runs? ls remove entry.exe, okay? It's no more in there. Run release. Runs, no problem. Okay, don't know what the problem is then. It works with pointers. Go figure. wrong. I guess maybe there are some additional restrictions. What I'm trying to do was actually safe, and some more advanced stuff wouldn't be safe. I don't know. I am not sure. But declaring new reference types and using it just worked no problem. Yeah. Types. Oh dear. What time is it? We could squeeze some more in, right? Let's start a little bit of types. Because this is kind of fun. I'm enjoying this live stream. All right, types. All expressions have a type that is known during semantic analysis. Nim is statically typed. One can declare new types, which is in essence defining an identifier that can be used to denote this custom type. I'm glad you're enjoying it, CPN. Awesome. These are the major type classes. Ordinal types consist of integer, bool, character, enumeration, and subranges thereof types. Okay, so ordinal types is basically everything that can be numbered, and bool, I guess, is 0 and 1. Character is from 0 to 255. Enumerations start, have numbers assigned to them. Floating point types, string type, structured types, reference pointer types, procedural type, and generic type. Okay, makes sense. All right. Ordinal types. So we start with the boring old numbers. Ordinal types have the following characteristics. Ordinal types are countable and ordered. This property allows the operation of functions such increment, ordinal or ordinal, I guess, and decrease on ordinal types to be defined. Ordinal types have the smallest possible value accessible with low of the type. Trying to count further down than the smallest value produces a panic or a static error. An ordinal type has the largest with high. Again, going over that will produce an error. Integers, bool characters, and enumeration types and subranges of these types belong to ordinal types. A distinct type is an ordinal type if its base is an ordinal type. Sure, so distinct types basically inherit that ordinality, let's say. So all that is pretty straightforward, just long to read. So let's look at the predefined integer types, all right? These integer types are predefined. Int, the generic signed integer type. Its size is platform dependent and has the same size as a pointer. This type should be used in general. An integer literal that has no type suffix is of this type, if it is in a range of this and that. Okay. Otherwise, the literal type is int64. So we basically, if we define literal that fits between those two, it will be used as integer. But if it's larger, it would default to integer 64. Even if your platform default is integer 64, this will kind of go to int32. Interesting. Oh no, it would just go to int. Okay. Okay, so it will be int, which could be this or that, depending on the platform. Okay. Int XX. Additional signed integer types of XX bits use this naming scheme. For example, int16, int8, int16, 32, and 64. Literals of these types have the suffix IXX. Sure. Then we have uint, unsigned integer. It's platform dependent, just like before, and just the suffix. And the same thing with additional ones. Yep. Follows the same rules. In addition to these usual arithmetic operators for signed and unsigned integers, like plus, minus, multiply, There are also operators that formally work on signed integers, but treat their arguments as unsigned. Huh? That formally work on signed integers, but treat their arguments as unsigned. Huh. They're mostly provided for backwards compatibility with older versions of the language that lacked unsigned integer types. Ooh, that will have been tough. And these unsigned operators for signed integers use the percent suffix as convention. So this is old stuff. Don't use it unless you absolutely have to. All right. Automatic type conversion is performed in expressions where different kinds of integer types are used. The smaller type is converted to the larger. So yeah, if we add int 8, int 16, and int 32, everything will default eventually to 32 because that's the largest one used. A narrowing type conversion converts a larger to a smaller type. For example, int arrow from int 32 to int 16. A widening type conversion converts smaller type to a larger type. For example, int 16 to 32. In Nim, only widening type conversions are implicit. All right. So if we have 5 as int 16 and just normal integer, if we add 16 to that normal integer, okay, so I guess this is context sensitive. It'll figure out that this is within range of 16, so it'll be fine. This plus int is larger, it will default to the larger. This and that is 32, is larger than 16, it will default to int 32. Okay, I like that this will be defaulting to what if it can fit in this one. That's awesome. However, int literals are implicitly convertible to a smaller integer type if the literal's value fits the smaller type, and such a conversion is less expensive than other implicit conversions. Okay, so -16 produces, and yeah, exactly. For further details, see convertible relation. All right, and this is another fun type, subrange types, because this is really powerful if used properly. Like, could be bonkers. All right. A subrange type is a range of values from an ordinal or floating point type, the base type, to define a subrange type. One must specify its limiting values, the lowest and highest value of the type. For example, we can define a type subrange that is a range from 0 to 5, or a positive float from 0.0 to infinity. Or another positive, in this case will be integer, which is from 1 to the maximum represented by the integer. Okay? Subrange is a subrange of an integer which can only hold the values from 0 to 5. Positive float defines a subrange of positive floating. Okay. Not a number does not belong to any subrange of floating point types. Assigning any other value to a variable of type subrange is panic or static error. Assignment from the base type to one of its subrange types are allowed. We've got writed by Cocoa type. Hello to you too. How are you doing? How is everyone doing? What were you doing before the raid? What kind of content? This is fun. We got rated when we explore interesting subject of ranges in the Nim language. iOS app development. Oh, this is gonna be drastically different. We're going through the manual of the Nim programming language to explore a little bit more rare topics. You can think of the Nim programming language as language that kind of looks like Python because it has those indentation, lots of similar syntax, but has static typing, like, proper static typing, and has garbage collection, but it's compiled to C++ or C, and therefore it's, normally compiled and really fast. You fall in a similar bucket of not game dev. I'm doing game dev on Mondays, but again, Nim and Unreal Engine, so very, very weird combination. So what I was reading about is those sub-ranges where you can define your own kind of integer values and float numbers to limit them. And I wanted to play with it. So I have the subrange type, so I can make a new variable of a, which will be of type subrange, right? Subrange. And that means that I can give it a 4, right? This will be fine. I give it a 5, it's fine. I try to assign 6 to it, we have an error. So it's literally can go only from there to there. That will be interesting because you could make, something like a new type called month ID or something, which is range from 1 to 12. And therefore, you could make a month, whatever. What would you call it? Let's say how much money earned per month, right? Earnings per month. And we'll just define it as an array where the index is the month, or maybe not month number. Let's call it that way. And we just assign it a float number, okay? Let's ignore all these other ones for now. And we just define our earnings that way. And therefore, when we go over things, we just can't go with something like earnings per month. Let's say 13 is this. Or can we? It's not complaining. Why? Can I run it? But I don't know. Okay, build failed. So it didn't even build because it says this isn't within that range. So yeah, I can see you could just define various types and you could, then, maybe here it's obvious, but then you could make a procedure like set earnings, right? And you just say which month, and it's a number. You can still operate with just normal numbers, like, set earnings, like for the month 1, which is this, but it will prevent you from doing like 20 because, sorry, 20 is not within the acceptable range. So, that's something. Yeah, when I try to run it, it will just complain like, nope, you can't set it. Month number isn't valid. That's awesome. And it's interesting that you can also define it for floats. What's the range of floats, including infinities, or just use numbers from other types? Interesting. Okay. More language should have that feature. I absolutely agree, because this is like crazy safety, in my opinion. The thing is that this is compile time. So you have to define it. You can't define it like on the go. I tried and I failed because I want to do weird stuff. But as long as you know already those numbers ahead of time, you can utilize it and have, just more safety, which is fun. I mean, the basic thing is that I like to think, which is game dev related, would be directions of the world, which is, you have 8 directions, and you can just specify them that way. Or you can use an enum. Okay, predefined floating point types. The following floating point types are predefined. We have float. Okay. It's just generic, but now it's always mapped to float64. But then we have also float32 and float64 if we want to be explicit. Automatic type conversion and expressions with different kinds of floating point types is performed. See conversion relations. Okay, further details. Arithmetic performed on floating point types follow the IEEE standard. Integer types are not converted to floating point types automatically and vice versa. Okay, makes sense. You need to be basically explicit if you're converting between floats and integers. Nothing's gonna happen automatically. And we have this whole IEEE standard defines 5 types of floating point exceptions. I'll ignore that. This is just common for every language. And those exceptions are either ignored during execution or mapped to the Nim exceptions. Bunch of them. These are basically all considered defects, and defects, I believe some are kind of ignored. Nim provides the pragmas, not the number checks, and infinity checks to control whether the IEEE exceptions are ignored or trap a Nim exception. Yeah, so you can just specify to turn them on, and then actual exception will happen. Without that, it will just not do the checks and panic if it happens. In the current implementation, the zero defect and inexact defect are never raised. Float overflow defect is raised instead of float division by zero defect, and there is also float checks pragma that is a shortcut for combination of not a number check, infinity check pragmas. Float checks are turned off as default. Okay. The only operations that are affected by the float checks pragmas are the plus, minus, times, and division operators for floating point types. An implementation should always use the maximum precision available to evaluate floating point values during some semantic analysis. This means expressions like 0.09 as float32 plus this float32 equals this as float64. Is compared to this plus that are evaluating during constant folding are true. Constant folding. I guess that means when we add up and perform operations purely on constants to just pre-calculate them and therefore have all that set already, pre-calculated results. Like this will be evaluated to 0.1 and just replaced by the compiler, and this will be evaluated also to 0.1 replaced by the compiler. Okay. Sure. Let's move to something more interesting. Boolean type. The Boolean type is named bool in Nim and can be one of the two predefined values, true and false. Conditions in while, if, else, if, and when statements need to be of type bool. Okay. So we have ordinal false equals 0. The condition holds. So, because Boolean type is considered to be ordinal type, I guess we can convert it, and false will be 0, and true will turn to 1. Okay. And operators not and all those are defined for the bool type. The and or operators perform shortcut evaluation. Awesome. Shortcut evaluation means that, for and, if one of them is already false, the first one, it will just not even consider the other one. While for or, if the first one is already good, it won't bother evaluating the other one, right? What is the difference between if and when? That's a good question. So if is just, how the hell was it? That's a good question, because I recall if is like normal if in the language, but when I believe is evaluated during compile time. What the hell was it? Let's ask it. What's the difference between if and when in Nim? Because I believe with when you can just do some extra checks during compilation time. I know it has its use, but I forgot. Because another feature that you don't use often. Come on. So, key differences. Evaluation time. If is evaluated at runtime, when evaluated at compile time. So, when is used for conditional compilation and compile time decision making. Expressions, basically, when is everything compile time. So, if is normal, but when. So, basically, when, and you can just, I know, it's define Windows, print this, else if, do that. So, you could, in theory, set some values purely during compilation time, like, a little if statement. Yeah. There you go. There's that feature. And I believe this feature is actually used a lot. Surprisingly a lot. We'll get to that. At some point, 30 streams later, we'll get to the keyword. Alrighty. So we have shortcut evaluation, and the size of the bool type is 1 byte, which is awesome. Then we have character type. The character type is named char in Nim, or char. I never know how to read it properly, like pronounce it. What do I say? Char as character or char as charcoal? I don't know. Its size is 1 byte, thus it cannot represent a UTF-8 character, but just a part of it, and is the rune for Unicode characters, which is defined in Unicode module. Yeah, so character, yeah, not much here. Char is in charcoal. Yeah, I prefer that too. Char. Weird. Yeah, I didn't get like formal education for programming in English language, so that's why I'm missing out on it. Don't know what's the proper pronunciation. But if char is fine, then I'm fine with that. That's the one I prefer. Enumeration types. Oh, enumeration types are actually pretty powerful in Nim, so that's another fun part. Enumeration types define a new type whose values consist of the ones specified. The values are ordered. For example, we can define type direction, which is an enum, and we just give it north, east, south, and west, okay? And now the following holds. If we convert it to a number using the ordinal, the first one will be 0, the second one will be 1, 2, and 3, okay? And therefore, we can notice that after we have this defined, we don't have to specify direction.west, because north, east, south, and west are already not ambiguous. Are ambiguous? That's the word. That there's nothing to confuse it with. It will just, Nim will figure it out, therefore no problem. Just use it, don't bother with the direction thing, okay? But if you want to, you can specify, because why not? The implied order is, yep, and the comparison operator can be used with enumeration types. Instead of north, the enum value can also be qualified with the enum type that resides in. Exactly, we can just call the type .north. For better interfacing to other programming languages, the fields of enum types can be assigned an explicit ordinal value. However, the ordinal values have to be in ascending order. A field whose ordinal value is not explicitly given is assigned the value of the previous field plus 1. So an explicit order enum values can have holes. So you can say that the token type enum, the A is 2, B is 4, and C is 89. Okay? However, it is then not ordinal anymore. That's the thing. If you have holes, it won't be counted as a number anymore. So it's impossible to use these enums as an index type for arrays. The procedures increment, decrement, successor, and predecessor are not available for them either. So yeah, the whole thing about enums is that you can actually use them as a type for an array. Because in the Nim language, let's say we have that let's say direction, right? Enum, and we'll just do up, down, left, right, right? Something like this. So this should be ordinal. Therefore, we should be able to specify that var whatever distance. We can specify that it's an array where the index is direction and the value held is integer. Okay? This way we just define an array that to specify it, we just do that. Distance in each direction. Therefore, we can say echo distance up, for example, right? Just like that. We could, in theory, say 3. No, it won't be happy because we give it an integer. It expects direction. So there you go. That's what it can do with it. But if we would specify that it's a token type, okay, which in this case will be 3 values, it won't be happy because it has holes. It doesn't know how to assign it to an array. It just doesn't make any sense. So that's that part. Taras, see you sometime later. Have a good day/night, whatever it is for you. So that's basically the difference. The moment you have holes, there's a problem. But what if we have just 2, 3, and 4? That works. Okay. First element is 2, 3, and 4. So that's that. And of course, we would need to do this B. Looks weird, but possible. And of course, it should be possible to just make, I don't know, tomato, pear, and whatever vegetable, right? A carrot. So you can specify that you want to get a pear, distance to a pear, right? Possible if you want to, works. Print it, right? 0. There you go. They're all zeros. But hey, that's possible. And you could just say, echo the carrot is an ordinal of, that's not a carrot. So that should take the number out of that, which should be 4. So let's see if it actually works. Yes, the carrot is 4. There you go. Works. So that's basically the whole idea about having holes or not holes in enum, and then being ordinal or not being ordinal. And therefore, because they're ordinal, you can actually do something like for I and token type. Is that possible? Run. Yeah, there you go. You can just, for all the values inside the thing, you can just iterate over all the enums. Or maybe you want to iterate over from pear to carrot. And sure, there you go. It's possible because these are just act like numbers. So yeah, fun stuff. Alrighty. So the compiler supports built-in stringify operator, $, for enumerations. The stringify's result can be controlled by explicitly giving the string values to use. Oh, look at that. So we can specify that the value A is 0 for the number, and it holds this string. Value B holds this string and will have value of 1 because it's this plus 1. This has, I guess, empty value for string, and this one will have ABC. I want to print that. I want to see what the hell is going to happen. Okay, we have this type, my enum, For I in my enum, echo, let's do literally ordinal of I, comma, space, and the I, which will be printed out with a dollar sign, okay? Run. So we have my value, value B. Oh, look at that, value C. So it just took this as a string label. Okay. Great. So by default, if you don't override it, it will just print out those. Good to know. That's another feature that I'm missing, for example, in some other languages where you want to convert between strings and stuff. Yeah. That's awesome. So easy to use. As can be seen from the example, it is possible to both specify the field's ordinal value and its string value by using a tuple. It is also possible to only specify one of them. Yeah, it's interesting. It's like suddenly gives you an idea, like, hey, enum can be a lookup table from an integer to a string, right? Relatively easy to implement suddenly, and you can refer to them instead of as numbers, but as specific labels, so you have type safety. So yeah, that's fun, and you can extract either value from them if you want. The only thing that we don't have is from a string to an enum, but you could probably write a macro that does that, or maybe there is already a macro for that. You could actually, wow. So if you take that, this is enum, right? There's nothing stopping you probably from making like something like constant. What the hell would that be? Oh no, this will need to be an array or something. No, I mean, you can just predefine some kind of lookup table and probably make it constant to some extent, and just have it load up or whatever. I mean, var string to enum is, and I don't know how to define maps table. Oh yeah, string to my enum, and we just need to import standard tables or something like this. And this could be basically, yeah. Can I just do block where we do result is this, and then we do for I in enum. Whoa, that's not nim. This is that, and we want the no, we want that. Okay, yeah, there we go. And that should be it, I guess. That is the result. No, it doesn't have result probably. So var result, and we do return result. And therefore, we suddenly should be able to do something like echo string to enum, and we take, for example, my value a, okay? And this should print out 0. Oh no, dot ord to get ordinal out of it. So this should print out 0. Return not allowed here, really. Okay. Will that work? Yeah, return 0. So we just made a lookup table of the whole thing from the other direction, and bam, there you go. And you could probably make it more generic than this mess. Fun tinkering. Yeah. And this is the confusing part, I remember. An enum can be marked with a pure pragma, so that its fields are added to a special module-specific hidden scope that is only queried as the last attempt. Only non-ambiguous symbols are added to the scope, but one can always access these via the qualification written as this, that. So let's see. We have my enum, which is pure, value A, B, C, D, and A and B. While we have other enum that has value X, Y, Z, and also A and B. So if we do echo value A, it will return that one. B, unclear whether it's this or that. My enum A and B is okay. Would that be a problem without pure? I forgot. I had a video about that subject at some point. So we save that, right? We run it. And yeah, this is ambiguous. So we would need to specify that we want that. But what if I don't have the pure? What if I remove the pure stuff? It's still gonna complain, right? So what's the problem here? Let some value will be of type my enum. And we're gonna say it's A and B. Can I do that? Can I assign A and B and we'll figure it out as my enum? Run. Yeah, that worked. What if I'm gonna make them pure? Will that change anything? Run. Yeah. I don't remember what pure was meaning. That was the one thing that I remember being really confused about. Oh, I remember. Isn't it that the pure was required back then, but now by default all of them are pure? I think that's the case, that this is kind of outdated. I will need to search for it. Because, it works like this by default. Enum value names are overloadable, much like routines. Enum value names are overloadable, really. If both of the enums T and U have a member name foo, then the identifier foo corresponds to a choice between T foo and U foo. During overload resolution, the correct type of foo is decided from the context. If the type of foo is ambiguous, a static error will be produced. So we have two enums, E1 and E2. They both have values. One has, value 2 as 4 and the other one has as 1. Constant lookup table is U value is 1, value 2 is that. No need to qualify value 2 known as E1 value. Yeah, because we already figured it out that we started with that. And we have proc E1, disambiguation and case statements. So we do E, value 1, value B. But we're not using E2 anywhere. This example doesn't make sense either. I think this is like old examples from like older versions of Nim or something that weren't updated. P value. I mean, P dot value will be, we give it value 2, which should figure out that's E1, therefore will be that. Oh, I guess that's the whole idea, that it does the overloading, right? So we'll figure out that, oh, it's for that type, and therefore we'll print out 2. Or in this case, it will be echo B. Yeah, there we go. Okay, kind of weak, obvious. In some cases, ambiguity of enums is resolved depending on the relation between the current scope and the scope the enums were defined in. Okay, in A.nim we have this guy, and B.nim we have this guy. We imported A. We have bar here. Echo ABC is bar. True. Okay. Sure. To implement bit fields with enums C bit fields. That's another powerful feature. Yeah. Alrighty, let's do a little bit more. And just a little bit more. I'm starting to stretch it. We have string types, then we have C string type, which is ugh. And then we have the whole structured types that I guess we're gonna leave for the next time. So let's just go through it quickly. String type. All string literals are of the type string. A string in Nim is very similar to a sequence of characters. However, strings in Nim are both zero terminated and have a length field. One can retrieve the length with the built-in length procedure. The length never counts the terminating zero. The terminating zero cannot be accessed unless the string is converted to the C string type first. The terminating zero assures that this conversion can be done in O1 and without any allocations. Yeah. This way, because we already know the length, we can just grab this whole chunk of code instead of ON, which will be looking like, is this zero character? Is this, until we reach the character. Therefore, conversion is instant. The assignment operator for strings always copies the string. That's important. That's very important. The ampersand operator concatenates strings. Okay, most native Nim types support conversion to strings with the special $proc. When calling the echo proc, for example, the built-in stringify operation for the parameter is called. Yeah, so this will call $sign for that integer. I want to look at that the assignment operator for strings always copies the string. Because that's one of those things that can get you sometimes when you start doing some more stuff. So let's say that we have a, var name. Let's do Ben. Okay. And let's do it this way. How do we check for copying? Zaka6 says the height allocation. It's all automagic. What do you mean where allocations? You mean in strings? Yeah. This is like merged between high and low level language, and therefore some things are just hidden. If we'll just do for second name is name, this is a copy. Overall in the Nim language, it looks like string literals and strings at runtime are mixed together. And can you push to a string? So that's a good question. Can you push to a string? I believe so. So let me show you this. We just define thing here, right? This is compile time is just, it's precompiled that this is gonna be that, whatever. Second name, this will copy this here because in Nim language, the assignment operator for value types, not reference type, for value types does copy, okay? And therefore, if we have a proc that, let's say, greet, it takes a name and prints hello and that name and exclamation mark, right? And we can actually do it this way, which is a little bit more pleasant. When we'll call it, we'll do greet name. This performs another copy. So we just copy that string again. Let's just make sure it runs. There we go. So we just perform a copy operation here and copy operation here by passing it here. Okay. And I don't know if in theory we made another copy by passing it to echo. I'm not 100% sure because maybe the compiler is, like By deep copy, I'm not 100% sure. Because as far as I know, string is a value type. Let's actually, because I made a little like Claude project that knows everything about Nim, and let's see if it can give us some kind of answer. Are strings value types or reference types? What is copied when I assign it to another string? Because I'm not sure. I know that there's one very important optimization to mark it as I know that the value won't be used somewhere else. Come on. Okay, in the meantime, I know that if we're gonna do this, we can do sync string. And that will suggest that, you know what? If that name isn't used after that anywhere, like in this case, we're not using that name anywhere else, it will basically move it there rather than copy it. Yes, Nim does have pointers. We can just do name pointer is just address of the name. Okay. And suddenly, if we'll restart the Nim suggest, because for some reason it broke, maybe at some point we'll get it working. Come on. So yeah, we can get a pointer and we could, pass it as a pointer, no problem. We could just probably also make it a reference because in Nim you can pass things as a reference, which is, garbage collected concept, or straight up as a pointer. And in this case, you have just a pointer which, doesn't do any reference counting and whatnot. So Nim strings are a bit of a special case. They behave like value types in some ways, but have reference-like characteristics in others. Okay. String implementation. Strings in Nim are implemented as a sequence of characters with a length field and a null terminator. They are all stored on the heap, not on the stack. Okay. So when you assign a string to another string variable, Nim uses a copy on write mechanism. This means initially only a pointer is copied, not the entire string contents. Both variables will point to the same string data. Okay, we have the copy on write. That makes sense. If you modify one of the strings later, Nim will create a new copy of the string data before making the modification. This is when the actual copying occurs. With value semantics, despite being heap allocated, strings in Nim generally behave with value semantics. You can pass string to a function, assign it to another variable. It appears to behave like a value type. And the copy and write mechanism allows Nim to be efficient with strings. Yeah. Yep. So it tries to optimize stuff behind the scenes. That's as far as I understand it. And Nim suggests doesn't want to start up. Let's restart VS Code and maybe that will work. Come on. Initialized. Oh, there we go. We see that the name string here is a pointer now. Or we could do var name reference, which, how on earth was I going to get a reference? I forgot how to get a reference to a string. There was a way to do that, but I don't remember. Yeah. But if we have a var, I believe we can do second name dot add. Yeah, it's happy about that. And we can pass second name and it will print with double exclamation marks. So we can modify it in that case. Yeah. So does address opt out of safe mode? Yes, the address opts out of safe mode. But I could make, how the hell do we make a reference? I mean, this will just involve copying in this case. because I can just make, we have name pointer, or we can do var name reference, which will be reference to string. Not name pointer, name. Was it something like this? Oh, lowercase. Oh, new. Something of this sort. Gosh, I forgot how to make, or maybe it's not possible to make a reference to a string. Don't remember now, but unless we just do new reference string. Gosh, that was a way to do that in some way. Okay, we just defined a reference string. Okay, yeah. And name reference. And to the value of that, we assign the name. Okay, this is like get the whatever. And now we should have a reference. So therefore, we have a safe, memory safe option here, and we can just pass it by that. You can even just define a type. String reference is reference string, and just use it here instead of that. And you have a little bit nicer semantics, I guess. And we could just say that this is a string reference, and we just pass it that way. Therefore, this won't work. Name ref will work here. Okay. And that's that. And echo doesn't like it now because echo doesn't expect a reference here. So we can extract the value out of it, and there we go. Yeah. And the same semantics are for the pointer. So if we would make it a PTR of string, and we wanted to do this, and then give it the name pointer. Somehow it works? No, it doesn't. We would need to do, again, extract the value out of it. But it's not stopping us to use the pointer. It works. Actually, in one of the previous streams, last Friday, I had a live stream where I was figuring out pointer types, and it's possible to, just have a pointer to a variable that doesn't exist anymore and just try to print it, and you get all the weird stuff. Yeah, and I think there's like yet another level of scary stuff, which will be, instead of doing address of name, unsafe address of name. Yeah, that's something you could do too. But what it means that we could make that the name is a constant. So let me just get rid of all the other stuff so that we have it, a little bit cleaner here. Okay. Uh-oh. Expression has no address. Oh no. Is it the rs for address? Oh, I thought that was okay. I'm wrong then. Yeah, because I thought that there was a way to actually modify constants. I'm sure there's a way, unless that's not possible. I'm not good with systems programming and stuff. I'm more of a high-level person when it comes to programming. So yeah, I'm not the best source of truth. Okay, where were we? So the ampersand operator concatenates strings. Yep, exactly. And most native Nim types support conversion to strings with the $sign proc, which is awesome because, and you can define your own operators like that for those procedures for $sign. And therefore you can take whatever you want and print it the way you want. And yeah, that's the fun part with this whole idea of the defining that operator. Because let's say that we have a type Let's do it once more. Type car is an object, have make, model, and year, right? And if I would do echo, which is equivalent of print, and my car is, and then comma, and we'll just do the car. We just need to make a car. So let car is, and we can just create a car like that. By the way, let is an immutable variable, whatever, runtime variable. Var is a mutable variable. Const is a compilation time only variable. Okay. And there's nothing stopping us from making that compilation time. Okay. So we'll just print that. Let's see what happens. Run. And it figured out, okay, I can take that type and I'm going to print it as this kind of standardized way. Okay. But what if we want to, print it nicer way? We can just do define a procedure. Yeah, $sign that takes a car. With those backticks, it means that we can kind of define weirder names for things. In this case, it's an operator. So unary operator that takes only one argument on the right side and returns a string. So we can just make it return, instead of car, we'll just make it something like return car make, car model, and we'll just do in parentheses will be car year and another parentheses. Okay, those ampersands are basically concatenation. And I'll answer a question in a second. And basically that means that now echo behind the scenes applies this, $sign operator to everything. So if we're going to run it, it's going to display it properly the way we wanted it. So you're asking if for global variables, you can just use let or var? Absolutely. Yeah, you can use const, var, and let everywhere. You don't have to be in some kind of context. So yeah, I could make it var, and in my procedure for printing, I could make it that I can actually make it that. Oh, that's another interesting thing to point out. So let's say that I have this procedure for printing, right? I'll define another one that takes a var car, which is a mutable reference to a car. Remember, car is not a reference, it's a value, okay? So if we have this car as, I know, constant, right? If we're gonna do this and this is gonna get called, we're gonna get this called. While if we're gonna add var car2 and we're just gonna make it, I know, Ford, I don't know what Fords are there, Mustang, year 1980 or something. We can make that, we'll just add mutable. Okay. Car, comma, and we're just gonna do another one, would be car2. Gonna run it now. One printed Honda Civic 2020, the other one printed mutable Ford Mustang. So suddenly, yes, these are global variables, and we can actually have function, operator, and whatever else overloading that differentiates between variable and between mutable and non-mutable things. So our printing could actually make the car.year is whatever, we just increment car year, right? And therefore when we run it, suddenly is 81. And it's muted it forever just by printing it, whatever. You can do that. So, yep, that's fun. I can go on this language. It's just mind-blowing what it can do with that. But yeah, I'm open for questions. That's always fun to answer to some curiosity. Continuing. While $P name can also be used, the $sign operation on a string does nothing. Note that we cannot rely on automatic conversion from an integer to a string like we can for the echo proc. Yeah, it just wouldn't make sense. Strings are compared by their lexicographical order. All comparison operators are available. Strings can be indexed like arrays. Lower bound is 0. Unlike arrays, they can be used in case. They can be used in case statement. So that's the one thing I don't like about language. That the case statement isn't very dynamic. You don't have pattern matching. That's something I really wish for in Nim. I know there are macros that kind of implement that, but it would be just nice to have it in core language. So yeah, we can do case over some kind of param string or whatever. And if it's this, or if it's this or that, do that, else, whatever. So we have case statements here. Per convention, all strings are UTF-8 strings, but it's not enforced. For example, when reading strings from binary files, they are merely a sequence of bytes. The index operation, SI, means the ith character of S, not the ith Unicode character. The iterator runes from the Unicode module can be used for iteration over Unicode characters. So basically, strings are very close to strings in something like a C language. So there we go, C string type. The C string type, meaning compatible string, is the native representation of a string for the compilation backend. For the C backend, the C string type represents a pointer to a zero-terminated array, a character array, compatible with the type character, pointer to a character in ANSI C. Its primary purpose lies in easy interfacing with C. The index operation, SI, means the ith character of S. However, no bounds checking for C string is performed, making the index operation unsafe. A Nim string is implicitly convertible to C string for convenience. If a Nim string is passed to a C-style variadic proc, it is simply converted to C string 2. Okay, so yeah, this is where you can use this function, printf, just import from C printf for args, header, stdio, h, and it just should work, right? Will that just work straight up? Because that will be kind of awesome. Save, run. There you go. This works as expected. Sure, because in the backend, it compiles with a C compiler. It's like Nim compiles down to C language and then uses a C compiler to compile C to your executable. So it's possible. You can interact with anything C, C++, or whatever very, very, very easy. Even though the conversion is implicit, it is not safe. The garbage collector does not consider a C string to be a root and may collect the underlying memory. For this reason, the implicit conversion will be removed in future releases of the Nim compiler. Certain idioms like conversion of a constant string to C string are safe and will remain to be allowed. Okay, really. A $proc is defined for C strings that returns a string. Thus, to get a Nim string from a C string. So we have a string hello. C string is just converted implicitly. And then your string is just printed out. That's it. C string literals shouldn't be modified. Oh, they shouldn't be modified. This is wrong, but will it compile? Or will it just not compile? Run. Illegal storage access. There we go. We can't do that. Okay. If the C string originates from a regular memory, not read-only memory, it can be modified. Okay, I see. So if we had it defined as var, there we go. And we convert it to a C string as var, then we can save to it. Okay, makes sense. Just from the string literal, it will be like, nope, this is read-only memory. So I guess that's why you can't modify constants, because there's a concept of read-only memory. Interesting. Okay. And C strings values may also be used in case statements like strings. All right. So I guess next stream will be all the structure types, array sequence types. What else? Open arrays. I guess we can see it here. How far do we go through? Order evaluation types. Yeah. Structured array sequence, open arrays, vargs, unchecked arrays, tuples, object construction, object variants. It's an interesting subject. Cast unchecked, assign default values. Bit fields are awesome. Reference and pointer types. There we go. Nil, mixing garbage collected memory with pointer. Procedural type. Oh, there's a lot in type relations. Overloading is absolutely awesome in Nim. And yep, statement expressions, all that stuff. And then we'll have our when statement at some point. Yeah. All that stuff. Iterators, procedures, methods. Holy moly, there's so much. I'm still scrolling. And there will be a list of all the pragmas. Oh. And yeah, at some point it will become like, let's skip that part because it's gonna be a little bit too much. But yeah, we basically finished at, where the hell did we finish? Types. C string type, and we'll start with structure type next live stream because I'm surprised I'm still able to speak. And it's nearly 2 o'clock here, so thank you all for watching. By the way, are there any burning questions? Just in case. I still have kind of 7 minutes. Okay. CPN, you're gonna start applying for jobs. Any advice? So is this gonna be your first like developer job? Because I recall you were saying that, you're basically prepping your portfolio and you're getting ready with all this stuff. Yeah, first job. Gosh, that's a good question. I don't know if I have good advice. How confident you are in your skills? That's my question. Do you feel like a total noob where you're like, I don't know what I'm doing? Or do you feel like, you have something to contribute? Because I must say, you're hanging out here on a live stream, learning about some random esoteric language and talking about it and poking around with it, weird stuff. It seems like you're interested in it and programming and stuff a little bit more than like, oh, I'm just gonna get a job and that's it. So yeah, what do you think is your skill level? Do you feel confident? Yeah, you're confident in your skills. Okay, that's good. So I think it's important to stay confident. Don't ever get, like cocky or something, because there's no point to that. And yeah, you're nervous, but the thing with applying for tech jobs is that sometimes it's a little bit of a grind. Because the thing is that each company has a vastly different requirements. Okay? Many companies will be looking, Some companies will be looking for how well you would fit in a team. Other company will be looking for, you know what, I want exactly those technologies from you. Another company will be like, you know what, I like that you know this and that. We're going to train you in something else. And because of that, it's really hard to find a company that will be actually looking for somebody like you. They'll be interviewing you, and unfortunately, 99% of what you will apply to will be basically screened by some kind of AI or some kind of other automated system that is unreasonable when it comes to removing stuff. For example, in a company I work now, I was talking with some senior management person, like one of the architects. It's a large company, like over 5,000 employees and stuff. But he was very surprised that I actually got hired by the company, because all their hiring filters, they absolutely require to have a computer science degree. I don't have a computer science degree. Therefore, he was astounded that I actually got hired. That how did I get to the interview process? And, from my perspective, it's like, I don't need a degree to be competent and to know stuff. And I got through a little bit different ways. Yeah, a lot of companies will just, the bots just will just scrap it. Like, nope. Therefore, when you will get through this whole, when you'll be going through this whole applying process, especially as a junior developer, you will need to go through some of that. It'll be a chore, okay? But don't get discouraged, because the whole thing is that most of the time it's just robots, and therefore they are not evaluating you. Therefore, this doesn't mean that there's anything wrong with your, resume or skills or something. It's just sometimes it's not possible to get through. So one advice I would give you is make sure you're on LinkedIn. Make sure you're marked on LinkedIn that you're open for hire, and maybe look around, find some ways to find some kind of people that will try to match you with a company. Because there are a lot of good, what would you call it? Agents, even working for companies that basically are specifically focusing on matching, okay, there's that company, I know that they look for people with those and those skills, or maybe at that and that level, and I'm gonna find people. And therefore, this way you can find a side channel to get to a company, rather than going on their website and apply for something. My last 3 jobs were jobs where I didn't apply directly, but they were, somebody found me on LinkedIn and matched me with a company. And I would say that's a good thing to find. And yeah, something like that. That will be the way I would find it. Other than that, I haven't applied for junior jobs in a long time, and then I know that landscape changed a lot recently. So for sure, I wish you good luck, and just persevere. That's the key here. Yeah, and yeah, just don't stress. It will take time, but it will get there eventually. All right. Your palms are always sweating. Oh yeah, I know the feeling, but yep, the moment you realize that, I mean, it depends on your situation. Yeah. Just there's just no need to stress too much. Especially that one thing with applying for those jobs will be that you won't be most of the time you won't be getting straight to the interview. First, you'll be talking with somebody from HR that would just ask some questions, maybe ask some follow-up, info that they need some more information. And only then they will actually schedule an interview. Or there's also another chance that they will be just giving you little tasks to verify if you can do something or not. It's really annoying, but that's how it rolls. So you'll have probably plenty of homework after that. All right. So, hey, thank you for chatting. Thank you for everyone else for watching. It was fun tonight for me. And yes, see you probably on Monday. I'll be doing more Unreal Engine with Nim. And yeah, we're getting close to finishing that one project in Unreal Engine. We'll see if we'll continue with Nim for Unreal Engine after that, or maybe we're gonna switch to something else because I have just so many things to try that I know. We'll see. But for now, thank you for watching. If you liked the live stream, feel free to like and subscribe. You can always add comments after the live stream has ended. If you're watching on Twitch, consider following on Twitch. And I wish you good mornings and good nights wherever you're watching. See ya.